So here's a question for you. How do we protect the confidentiality of our data? Well, we use encryption. Encryption can protect the confidentiality of our data. We don't want people who are unauthorized to be able to access our data and read it. And how exactly do we do that? Well, it really depends. It depends on the type of data. Well, there's more than one type of data. Well, we've got data at rest and data in motion, and it's a little bit different with each of them. So let's jump in and talk about that right now. So first of all, why use cryptography? Well, really it comes down to one word, and that is confidentiality. We want to protect the confidentiality of our data, which means we don't want those folks out there who don't have access to be able to read into our data. We just don't want that to happen. We want authorized users to be able to access and read the data. That's what it's all about. It's protecting that confidentiality because data isn't always on our network. Sometimes it's out on untrusted networks like the internet as it traverses the internet to get from one point to another. So that leads us to when we're dealing with cryptography, we have multiple types of data. And that's because data resides in two states. We have data in transit and we have data at rest. And really at transit, also known as in motion, like data in motion and data at rest. And we can use cryptography to protect this data and protect its confidentiality. So when we're using cryptography to protect our data, well, it does depend on whether it's data in motion or it's data at rest as to what type of cryptography we use. So let's start with data in motion. So we've got data in motion, and it's data in motion because it's moving across networks. Now, if it's on our internal LAN, our local area network, inside of our network, then it's on a trusted environment, and it doesn't necessarily have to be encrypted most of the times. However, once it leaves, once it goes through your firewall, goes out the router, goes to your internet service provider, and goes out to the internet, well, that is an untrusted network. At which point, we have the bad guys out there who might be looking to read your data. And that is something we want to avoid. And if we encrypt our data, well, then that data cannot be read by those bad guys out there. So how do we go about encrypting data in motion? Well, there's a couple different technologies we can use. The first one is SSL and TLS. Now, SSL is Secure Socket Layer, and this is really a thing of the past. SSL has been deprecated, which means it's really no longer used, but it's worth mentioning because you're still going to see it out there, but we just probably shouldn't use that going forward. It's not as secure. Now, SSL uses public and private keys in order to encrypt the data. So it uses two different keys, and this is known as asymmetric encryption. And it's asymmetric because it uses two different encryption keys. One key is used to encrypt it, a different key is used to decrypt it. And that is SSL. Now, TLS is transport layer security, so TLS is different. And that's because it is a type of encryption that connects two applications together. So if you've got app 1 over here, and you've got app 2 over here, and this could be actually like a client version of the application, and this could be the server side version of the application. What happens is the client will go out and talk to the server here, and it's going to say, hey, I'd like to do TLS or transport layer security encryption. So the server says, yeah, that's great. And what happens is they do a TLS handshake where they agree upon the encryption settings they're going to use. And once they define that, then they're also going to define a key that they're going to share. And that means both sides use that same key to encrypt and decrypt that traffic, and that's known as symmetric encryption. And it's symmetric because they use the same key to encrypt and decrypt the traffic. Now, since SSL really isn't being used anymore, it's deprecated, we should be concentrating on using TLS. However, there's multiple versions of TLS. And as of the recording of this video, you should steer clear of TLS version 1.0 and version 1.1 because they're no longer considered secure. So we should be using TLS version 1.2 or later. And that's something to keep in mind. So that's SSL and TLS. That's one way that we can actually encrypt data across untrusted networks because it's in transit going through those networks. And another way is to use something called IPsec. Now, IPsec is a protocol suite, and it's used to authenticate and encrypt data packets. So there's our encryption. And IPsec is actually used with virtual private networks, or VPNs. So if we've got network A over here and network B over here, what we can do is we can actually use IPsec and set up a VPN tunnel that will go between these two networks. And that's what we see here. We have a firewall here and a firewall here, and we've configured a VPN tunnel between the two. Now, any traffic that goes across this tunnel here, that goes through here, is actually going to be encrypted. So as it traverses the internet, all that data is encrypted and cannot be read, so it maintains its confidentiality. So again, IPsec is used with VPNs, which creates a secure connection between networks. So as that data traverses an unsecured network, it's okay because all that data is encrypted. So there we go. That's the second way we can encrypt data in motion. But what about data at rest? So data at rest is data that's sitting basically on a hard drive of some sort, and it's just not being used. The operating system is not reading that data. There's no users using that data. There's no applications using that data. It's sitting on the disk, not being used at all. So that is data at rest. Now, where do we see data at rest? Well, generally, it's going to be on a device that's powered off or not being used. It might be a tablet, it might be a laptop, it could be a PC, it could be a server that is powered off. Or it could be in a network storage device that has a bunch of disks in it and they're not being used. It's powered off at the moment. So how do we encrypt our data at rest? That's the question. Well, the answer is we need to use some type of disk encryption process. And there are several of them out there. Microsoft has BitLocker, and there are various other commercial options that are available on the market. But basically the idea is we want to do something known as full disk encryption. And when you do full disk encryption, it encrypts everything on the hard drive, and you are provided with a key. Now that key is the only way to recover that data. So you need to record that somewhere and keep it safe. But when we do full disk encryption, it helps to protect our data at rest. Now, you might think, well, my data at rest, it's sitting in my office. It's not a big problem, right? There's nobody going to go in there and steal it. Well, is there? There could be. There's been plenty of break-ins where organizations try to steal data. They might break in and steal a server or a computer or a storage device. And when they go to power it on, what are they looking for? The data. Oftentimes they steal people's laptops that they take home with them. They steal tablets, or these tablets and laptops might be lost. Who knows? But the idea is if the data on all of these devices is encrypted, then it doesn't matter that that laptop was stolen. That data is secured. It cannot be read. There was no data compromise. And that is key to data at rest. Now, when it comes to encrypting your data, yes, there are some risks associated with. As I mentioned, if you don't have the key that you were given or you use to encrypt data, well, that could be a problem. So one risk is loss of encryption keys. If you lose your encryption keys, there's a very good chance you're not going to be able to recover that data. So we need to keep those keys stored in a secure location so that we always have access to them if we need them. Secondly, too much access. Well, what do you mean by too much access? That doesn't make sense. Well, it's like this. If I take my data, this is my data here, and I go through and encrypt it, and I put a key over here, and I let anybody in the organization access this key so they can read the data. Is that good? Well, probably not. Because what am I going to be encrypting? Well, if I'm not encrypting, it's either all my data or some of it, right? And if it's all of it, then everything's encrypted. If it's some of it, only sensitive data is probably encrypted. Do I want to allow everyone in the organization to have access to the encrypted data? Well, probably not, because it's sensitive and not everybody needs access to it. Now, let's take this to a cloud scenario. If I subscribe to the cloud, right, to some cloud provider, and I spin up some servers up here, and I have sensitive data up there, and I encrypt this data. It's all encrypted. There we go. And there's my keys. So that's all encrypted now. Do I want my cloud provider to manage my keys? Well, the answer to that is probably no. Why not? Because that's giving them too much access. They need to manage the underlying infrastructure that allows me to run whatever services I want to. They don't need access to my encrypted data to do that. So I don't need to give them my keys, which kind of leads into key management. All of this here, these risks, loss of your keys, giving too much access to your keys. This comes down to key management. And that's what we're going to talk about right now. Key management rules of thumb. And of course, the number one rule is going to be protect your keys. And how do we do that? Well, we need to keep them safe. We need to know where they are, because we can't keep them safe if we don't know where they are. So that's protecting our keys. We've got to have some type of key inventory and a management process around our keys. We also need to practice something else. I'm going to put that down here, number 2. And this is separation of duties. And if you've been around security for any length of time, we've talked about security controls and administrative controls. One of them is separation of duties. And again, this is the idea is management of your keys. Not everybody should have access to the keys because not everyone needs access to the keys. We need to separate our duties. For example, back to the cloud. Does our cloud vendor need our keys? That is the question, and we answered that. The answer was no. They have a duty to make sure that the cloud services are up and running and redundant and working as expected. They don't need access to our data in order to do that, so we don't need to give them keys. And that's an example of separation of duties. We manage our keys internally as a customer. We don't need our cloud vendor to manage them for us. Speaking of which, there's a couple different key management methods when we're talking about cloud services. The first one is remote key management service, or KMS. Now, a remote key management service is where we have a key management system. That's an actual system that helps us to create keys and encrypt our data with the keys, and then it maintains our keys. So it's a management system for our encryption keys. Well, we keep this on premise, not in the cloud. We keep it on premise. However, when we do this, we have to make sure that there is connectivity between the cloud and our data up there and our key management system. So we've got to have connectivity. And that's because our data over here is encrypted. And when somebody tries to access it, it has to say, okay, well, let me decrypt it. So first I have to go over here and talk to the key management service to get the key. Then I can decrypt it. Then you can read the data. But if there's no connectivity between the two, then decryption is not going to happen. And that is remote key management service. There's another type of key management when it comes to the cloud services, and this is called client-side key management. And this is where the CSP provides a KMS solution. So the CSP is going to provide us with a key management solution that works with their environment. However, it resides on premise. Okay, that's a little bit different because over here we kind of choose our own KMS, but it does reside on premise. So over here, on the client side key management, we've got our KMS set up on premise, and it was provided by the CSP. And once this is set up, the client will generate encryption keys. They're going to take it, they're going to encrypt their data, and they're going to take that encrypted data, and they're going to upload it into the cloud. So it goes up there in an encrypted format. And then with this solution, the client is managing all of the encryption keys and the encryption process and the decryption process as well. So those are two different cloud key management methods. And that is cryptography, why we use it, how it can help protect the confidentiality of our data, and why we need to keep in mind that key management is so very important, because if we don't manage our keys properly, there is risk when it comes to encrypting our data. I hope it's been informative for you. I'd like to thank you for viewing. In order to properly secure our data, we need to control who has access to it. And this isn't just keeping those who shouldn't have access to it out of it, but also providing access to the data for those that need it to do their job. And this in the cloud is generally done through IAM, or Identity and Access Management. So let's jump in and take a look at IAM. So as I said, access control in the cloud is generally done through Identity and Access Management, better known as IAM. So let's break this down into its simplest form. This is the management of identity, so we'll say identity over here, and access. So that's what we're managing, identity and access. But what are these two things? So identity is a way to validate a user. So we're looking to validate a user, make sure they are who they say they are. And how do we generally do this? How do you get validated? Well, you might enter a username and a password. That's one way to do it. But there are other ways as well. Maybe you have a smartphone app, so you use an app as part of your authentication. Or you use a smart card type of device. You might do that. Or you might use biometrics, so that you're using your fingerprint or maybe a palm scan or something, but biometrics come into play. Or maybe you use several of these together in some type of multi-factor authentication or using multiple factors. So that's how we can identify someone, validate they are who they say they are. Well, that's the first part. Now we go over to the second part of access, and what's that? Well, that's controlling what a user can access. So once they do get validated, they're allowed into the system, but we have to figure out, once they're in the system or into our environment, what should they be able to access? And that's the second part of IAM, Identity and Access. Now let's take a deeper dive into IAM and take a look at the 4 different phases of IAM. The first phase is provisioning and deprovisioning of accounts. Now this is super important, right? When we have somebody new starting at the organization, well, they're going to need an account in order to work. And once they leave the organization and they're out there saying adios, well, once they leave, we need to deprovision their account so they no longer have access. And this isn't just local access to the files on the servers. This could be remote access via a VPN or some other way. So there's lots of different types of access, and we need to ensure that we fully deprovision their access. Now, that's not the only things that need done during provisioning and deprovisioning. What about provisioning updated access? Because today, we got Jan over here, and Jan is working on Project Y. Well, Project Y is in the books. It's completed. Now, Jan is working on Project Zulu. So we got Project Z that's being worked on. Well, we're going to need to update Jan's access and remove Project Y because she doesn't need that anymore. It's over with. And provide her with access to Project Z. So we also have to keep things up to date as we're going along, not just create new accounts and deprovision them, but update the accounts as well. Now, as we're creating these new accounts and managing permissions and such, generally we try to do this in some type of centralized directory service. And this is a repository for storing all the accounts and permissions and metadata about the accounts. That's really what this is, a big old repository. The most popular of these repositories that we use is known as LDAP, and that is the Lightweight Directory Access Protocol, which is based on the X.500 directory standard. And LDAP is what Microsoft's Active Directory uses, and LDAP uses a hierarchical format. So we have something up here, and then it kind of goes down like this, and this could break down into here. This is what I'm referencing as a hierarchical format. So it's some type of hierarchy that we set up. And LDAP, again, is probably the most common, and it's used by Microsoft's Active Directory, which has been around for quite a while now. Now, that's not the only type. I'm going to put a line over here. There's also something called Privileged Identity Management, also known as PIM. Now, what PIM is, it's an industry term, really, and it describes a type of solution that helps secure, control, and manage and monitor access to various assets, right? So what we're talking about here is this centralized directory service can also be known as a PIM. And there are various PIM solutions out there. You can go Google it, and there's lots of different vendors who have a PIM solution. But really, there's some kind of main things that they provide us with. The first one is some type of rule sets so that we can create rules for who can do what, right? And oftentimes these are around time and geography. So you can set up rules saying only certain people can access things at certain times or from certain locations. So we've got to have some type of rule sets. And there's also needs to be some type of auditing available, some type of audit requirement so we can turn on logging, we can do auditing, so we can find out who's doing what. And we also need the ability to use multi-factor authentication, because we can't just stick with the same old username and password. So these PIMs generally offer some of these more advanced options over here that we just talked about. And no matter what directory service you choose, it's really important to have some features of PIM for privileged accounts. And I want to call this out here. I want to make note of this and say, when I'm discussing a privileged account, that is a special type of account. We're talking about like administrator accounts or root accounts. Those are privileged accounts. They have lots of privileges. They can access like everything. And these accounts bring with them a high risk. Because if you had Joe Schmo, who's your day-to-day help desk person, and their account's compromised, well, they don't have a whole lot of permissions. However, if you had an admin account that was compromised, they have permissions to like everything. So that's why it's a high risk when we're talking about privileged accounts. And that's why it's really important that we add additional security to them. We make sure we're using things like multi-factor authentication. We're performing auditing, looking for abnormal activities. We're setting up rule sets if we need to. But we need to take the extra step to protect those privileged accounts. And that leads us right into step 3, privileged user management. And I mentioned it previously because I really want to stress how important this is. When we have privileged user accounts, again, we need to take the extra steps to protect them. We need to turn on our multi-factor authentication. We need to perform our audit reviews of our logs. We're looking for abnormal activity, things like successful and especially failed logins. So if we can try to identify maybe a brute force attack that's going on through multiple failed logins, we need to look at object edits. So like creating new accounts, that would be part of that. And it would be maybe changing permissions. These are things that are normally done by admins, right? Well, absolutely. However, we need to review those if we can. We need to perform like an end of the day. Hey, did you make this change? Yes, I did. Now, in a large organization, a global organization with admins all over the place, this would be very difficult. I don't get me wrong, I understand that. However, in a lot of smaller organizations, this is something that we can do and we should be doing. So again, it's very important that we take extra precautions when managing privileged user accounts. All right, on to our final phase of IAM. This is our authorization and access management. Now, break this down. Authorization. What is authorization? Well, authorization is the process of verifying a user's access. So many times we hear the term authentication, and we also hear authorization that goes right along with it. Well, authentication is the validating of a user, making sure they are who they say they are. Then once they get into the system, that's when we go through the authorization process to figure out what that user should have access to. So this whole process of authorization is basically figuring out what permissions this user has and privileges and what they should be able to access. So that's the verifying of it. But then we come into access management, and that's the actual providing of access. So first we have to verify what they can access, and then we allow them to access it. And that is the 4th phase of IAM, authorization and access management. And there we go, controlling access to your data. And again, not just keeping bad folks out, but letting those who need access to it to do their job, making sure they can do so. And we can audit the activities. That's very important. This helps us to address and reduce risk associated with access management. I hope this has been informative for you, and I'd like to thank you for viewing. we know that data has an endpoint, right? There's going to be a point when we no longer need specific data. And once we reach that point, how do we properly get rid of that data? How do we sanitize it so that nobody else can read it? And that way it doesn't fall into the wrong hands, especially when we're dealing with the cloud and our data is somewhere else, that we don't necessarily have the ability to go to that location, grab those hard drives and, like, drill holes in them or shoot them up or light them on fire or shred them. We don't have access to those. So how do we sanitize our data properly, especially in the cloud? Well, we're going to talk about that right now. Sanitization, that's what we want to talk about. The process of removing all the data from a device or a service. So we are removing the data so that it's not there anymore. We don't have to worry about it. We're not managing it anymore. It is gone. It cannot be compromised in any way, shape, or form. And that's what we want to do. We want to sanitize our data when we no longer need it, so it's no longer a risk. Now, how do we know that sanitization has actually taken place? That is a good question, especially when we're talking about the cloud. If I go to the cloud and I just delete a file, is it really gone? Well, probably not. You know why? Because on our servers within an operating system, when we go in and delete a file, we're just deleting a pointer to where that data existed on the hard drive. And that's because operating systems use something like a master file table. And what this does is it lists out a file name, and then it points to an address of where that lives on a hard drive. So it could be a spinning platter, it could be, an SSD hard drive, whatever it is, doesn't matter. This table points to where it is on the hard drive. And the operating system, when it wants to go pull a file, well, it goes and looks at this table to see where it's located. When we delete a file in an operating system, all we're doing is we're simply removing this line from the MFT. That's all we're doing. We're not actually deleting the file from the hard drive. Ooh, good point. Yeah, because that data doesn't actually get deleted until it gets overwritten by other data by the operating system. And it just does that by happenstance. As it's writing to the disk, it just happens to overwrite a file that used to be there, because it doesn't know about it anymore because it's not in the MFT anymore. Okay, great. So now we understand that. We know that we can't just go delete something and expect it to be gone really, because it's not really gone. So how can we properly sanitize something to make sure that data is gone? Because there's implications around sanitization not being complete. Some of those implications are data compromise. That's a big one. Because if you have a data compromise, it leads to other things. Basically, a security incident, most likely. It could lead to non-compliance. It could lead to reputation damage. It could lead to fines. And the list goes on and on and on. So there are some serious implications around sanitization not happening properly. All right, now that we know how important it is, I'm not going to harp on this anymore. Let's talk about different ways to properly sanitize data. Starting off with physical destruction. That's where we take our drives or whatever our data is stored in. It's a drive of some sort, might be a USB or SSD, doesn't matter. Whatever it's stored on, we take that, and the best way to deal with that is shredding. And I'm not talking about a paper shredder. I'm talking about a super giant, big, massive industrial shredder with big metal teeth. And you drop these discs into here, and what it does is it just absolutely pulverizes them into little bits. So there's no way that data could ever be recovered. However, when we're talking about the cloud, well, we don't have access to these hard drives, these physical drives. We can't just go to the cloud vendor and say, give me your drives that my data is stored on. Well, no, it doesn't work that way because, remember, generally we're dealing with a shared environment, shared infrastructure, resource pooling. So all these different clients' data are on the same drives. That's good to understand, right? Because this just isn't feasible in the cloud. All right, well, what are some other options? Well, how about degaussing? That's where we take a big old magnet, we stick it to a hard drive. Now, this is a spinning hard drive. This does not work on SSDs because they don't use magnetic fields, so it couldn't work on SSD. But the old spinning disk, absolutely. You take a magnet to that sucker, and you're going to erase all that data pretty darn quick because these are stored via a magnetic field. And basically, we use this magnet to completely destroy this magnetic field and erase everything. And it works quite well. But in the cloud, can we go get those hard drives? Nope, sure can't. All right, let's go on to the next section. How about overwriting? What is overwriting? Well, that's just overwriting data with patterns and multiple passes. So the idea is if we have this data here, and we'll just call it data, and I want to write over this data, and I fill it in with a pattern like this. Okay, my data might still be somewhat recoverable, and then I do it again on another pass, and I go like this. There we go. Well, that's pretty good too. Maybe I do another pass, and I overwrite it with this pattern. Well, it makes the data very hard to recover. And is this an option? Yes, it's definitely an option in the cloud, but it can take a long time if you're dealing with large amounts of data. But it is an option in the cloud. Lastly, crypto shredding, also known as cryptographic erasure. Now, here's what we do. We take our data, it's our original data here, and what we do is we encrypt it with a strong type of encryption. We're talking about AES 256 or something, some good type of encryption, okay? And then what comes out of that? Well, out of that comes our encrypted data. There we go. Okay, well, but that's not it. That's not where we stop. What we do now is we take this key and we run it through a different type of encryption, all right? And it actually encrypts this key at that point. So it's encrypted. So we've kind of encrypted the encrypted. And now what we're going to do is we're going to delete all of it. That way you can't easily recover this. And that's known as cryptographic erasure because we encrypted the encryption key and then we deleted the encryption key that re-encrypted the encryption key. I know it sounds like I'm talking in circles at times, but that is cryptographic erasure. And that is your absolute best option when you're dealing with the cloud and ensuring data sanitization. All right, are there any other options? Well, truthfully, these are the best option because if I was to take my data, here we go, and I encrypt it, so now I have my encrypted data, and I delete this key, the single key, and go ahead and delete that data. Well, this really isn't good enough because, remember, just deleting it doesn't actually remove it from the drive, right? Not from the data storage. It's still there. We just removed the references from that master file table. So theoretically, if someone had access to that storage, they could use forensic techniques and recover this key and the data and decrypt it. So yes, it would be a lot of trouble to go through. However, you know what? It's still pretty possible. And that's why cryptographic erasure is your best option. So that has been data and media sanitization. And when we're talking about the cloud and sanitizing your data, cryptographic erasure, aka crypto shredding, is going to be your best option. I hope this has been informative for you, and I'd like to thank you for viewing. When we're using cloud services, we know that there is a shared responsibility involved. And when it comes to network and virtualization security, hey, that's true as well. Some things the CSP or cloud service provider will secure, other things the customer needs to secure. So let's jump in and talk about network and virtualization security in the cloud. So the first question is just how different from on-premise is the cloud? And the answer is, well, it varies. And I say that because different vendors provide these services differently. But in general, it's not really all that different. Yes, things are in different locations. They might have different names. But the underlying infrastructure, our systems, our networking, they still all work the same. They use the same protocols. It's just that we have to figure out how they're implemented so we know how to tweak them. With that being said, you still need to understand the basics of information security for systems and networking and protocols and all those things. Now, starting off, cloud is using virtualization. just like many of us use virtualization on premise today. So if you're not familiar with virtualization, we're going to talk about hypervisors to get started. So what is a hypervisor? Now, a hypervisor comes in two different flavors, really. It can be either a type 1 hypervisor or a type 2 hypervisor. Now, they both do the same thing. So let's talk about that first. So what does a hypervisor do? Well, it allows us to create virtual machines. So we're talking a Windows server or a Linux server or a Mac server, whatever it might be, but it is a virtual instance. And what a hypervisor does, it allows us to build this, and then it acts as a go-between between that VM and the underlying services like networking and storage and CPU and memory, all those things, and access to physical USB devices that might be plugged into this server. So that's what a hypervisor does. It basically does all the middleman work for virtualization. We as administrators, we just log in and we create our virtual servers and we give it CPU and memory and storage and networking. We do that through a menu, right? Makes it pretty simple. We don't have to worry about how all the underlying ties together. That is the job of the hypervisor. So that's what it is. Now, I said there was a type 1 and a type 2 hypervisor. Well, a type 1 hypervisor is known as a bare metal hypervisor, meaning you install it as an operating system onto a server like this one down here. So what we did is we installed the hypervisor directly on it. And let's move this over here actually. Let's do an arrow and let's do example of type 1. So examples of type 1 hypervisor. These are commercial examples, so you can get an idea of what I'm talking about. Well, we got VMware. VMware is very popular with virtualization, and they run a vSphere ESXi server, and that is a bare metal hypervisor you install on a server. Another one would be Windows Hyper-V. Now, Hyper-V you can run as kind of a bare metal hypervisor, or you can run it as a service within Windows. It really could go either way. So I don't want to harp on that too much, but the idea is it can be bare metal. Another example is Citrix Zen Server. Another example is KVM. And then one more is Red Hat Enterprise Virtualization. So those are 5 examples of your type 1 bare metal hypervisor. Now, a type 2 is a bit different. It's actually an application that you install on an operating system, and it allows you to do virtualization within the operating system. So it's a little bit different because I could have a machine over here, a server. It could be running, I don't know, it could be running Windows, and I install an application on here, and through that application, I do my virtualization, and this is a type 2 hypervisor. Let me give you some examples of a type 2 hypervisor. So we'll put type 2 examples. Draw a little line there, make some room. Now, examples are VMware Workstation, VMware Fusion, if you're running on Macs, VirtualBox, and Microsoft's Virtual PC. Those are 4 examples of a type 2 hypervisor. So you could run them bare metal directly on a server or through an app on another operating system. So that is the hypervisor, and it's really important that we understand that because everything we do in the cloud is based on virtualization. Now let's move on and talk about a couple different types of virtualization attacks. So here we're looking at hypervisor attacks, and there's really 2 types we're going to look at. The first one's called hyperjacking, and that's where an attacker will actually take over a virtual machine monitor or a VMM, and this is just some type of virtual machine management product. There's all different types of them out there that are on the market, and what they do is they allow you to easily manage your virtualized environment. So what we do is we get an attacker out here, and that attacker finds a way to take over your VMM, and then of course they have access into your hypervisor platform, so they basically hijack it, and that's called hyperjacking. Now the next one is called a VM escape, and that's where the attacker tries to gain access into one of the virtual machines running on the hypervisor. Once they do, they place code in the boot sector of that device. So they put some malicious code down here at boot. And then what they'll do is they'll cause this to crash, There you go. They crash the operating system. And then the idea is it boots and runs this malicious code that then gives them access directly into the hypervisor. So they're able to then access the underlying hypervisor, and from there they'll do whatever they can in order to take over that hypervisor. So those are two of the most popular types of attacks. Moving on, we're going to talk about virtual switch attacks. Now, the thing with a virtual switch attack, it's the same thing as a regular on-premise network switch attack. There's three primary types of attacks. We're talking about VLAN hopping as the first one, and that is hopping between VLANs. If you're not familiar with a VLAN, let me explain it real quick. What we got here is our switch, has all these different ports on our switch. And the idea with a VLAN is what we can do is we can segregate these switches into their own virtual network or virtual local area network VLAN, right? Okay, so why would we want to do that? We're going to talk about that. We're going to say, let's take these first three ports, we're going to put them in the red VLAN, and then we're going to take these last three ports and put them in the blue VLAN. If I connect a computer here, there we go, plug that in, and I connect a red computer, there we go. Guess what? These two computers cannot talk to each other. Not possible, unless they go through some type of layer 3 or above device, meaning a router. And that router could also be a firewall, or it could be a layer 3 switch with routing capabilities. Doesn't matter. The idea is it has to go through another device before they can talk, and here's where we can set up access control lists or security rules saying, no, red cannot talk to blue and blue cannot talk to red. Or we can say, yes, they can talk to each other. It's up to us. It allows us to centralize our security rules, because if I have a switch like this one here with no VLANs on it, and I plug a computer in, a red computer, and I plug a blue computer in, guess what? There's no virtual LAN. There's no VLAN. So they can talk to each other. But I don't want that to happen. Well, that's why we have VLANs, because we plug all our computers into these switches. And if I didn't have VLANs, I would have to have a different switch for every different network. Well, that's crazy. I'm not going to spend all that money to buy all those extra switches. I might have 50 VLANs. I'm not going to buy 50 switches for every network closet, right? You see where I'm going with this. Here, we can not do that. We can get rid of those switches, and what we do is just use VLANs to help us segregate our networks into little networks that can't talk to each other unless they go through some type of layer 3 device. So that's VLANs. Now, VLAN hopping is where we have somebody, maybe an attacker, and they want to gain access from the red VLAN where they're plugged in into the blue VLAN, because that is where our sensitive data is. That's where the prize is, So how can they hop between VLANs? Well, that's the type of attack we're talking about. They attempt to jump between VLANs that they shouldn't have access to, and there's different tools and different ways to do it. You should just be aware that it is a type of attack. So what they're going to try to do is jump over to the blue VLAN and access their data when they shouldn't be able to. And that process is VLAN hopping. All right, I'm going to make a little room here so we can talk about our next type of attack. All right, the next type of attack is ARP table overflow. Now, the way a switch works like this here is it is a layer 2 device, meaning it routes via MAC addresses, and it doesn't really route, it more switches, right? But it moves data around based on the MAC address of the data it receives. Now, here's the thing with a switch. Let's draw a switch up here. If I have a computer plugged in here and a computer plugged in here, there we go, and I have maybe an uplink to the rest of the network, what happens with the switches? They learn when data goes through them. So if a network frame, that's a layer 2 piece of data, comes in here and its destination is, let's say we have computer A and computer B, and its destination is computer A, it's only going to send it to computer A. And if a piece of data comes in looking for computer B, it's only going to send it to computer B. But if it gets a piece of data in that's looking for computer C, and it comes in here and it doesn't see a C, there's no C plugged in, I don't know where C is, and it's all based on the MAC address. Well, what happens is it's going to send it out every port on that switch, because it's looking to see if any of those ports respond. If it does respond, then computer C lives out that port. And it records all this MAC address information in something called the ARP table. And ARP tables can only hold so much data, right? It's X number of MAC addresses, and it depends on your switch, and they all have different amounts. But here's the thing. An attacker could actually plug in here, and with certain tools, they could fill this ARP table up to capacity and cause it to overflow. What happens when it overflows is the switch starts forwarding all data out all ports. And you see the problem here. This now becomes a security problem, because if I'm running a sniffer as an attacker on here, I can now see all data going through this switch, which I shouldn't be able to. Switches prevent that from happening. It's kind of a security feature. So an ARP table overflow allows an attacker to be able to see all data going through the switch they're plugged into. And if there's data going through this switch and out to another switch, well, guess what? It sees all the data traversing the switch as well. And that is an ARP table overflow. All right, let's clear some of this out so we can look at our final type of virtual switch attack. Now, our final type of virtual switch attack is known as ARP poisoning. So we're playing with ARP again. Now, the way ARP poisoning works is we have an attacker over here, and we have, let's say, a router over here, our gateway that goes out to the internet, or it could be a DNS server over here where people ask for DNS information. An attacker will spoof the MAC address of their machine. They'll take the MAC address of a DNS server or a gateway, and they will act like they are that server or gateway. Their computer will say, hey, this is my MAC address, even though it's really the MAC address of a DNS server or a gateway. And that will cause the switch that they're plugged into to send information that's destined for that router or that DNS server over to them because they're closer. So that way, these computers over here that are on this switch, all their traffic headed out to the internet is actually going to get sent to the bad guy. And then he's going to act as a proxy and forward them over to the actual gateway. So what does this attacker become? A man in the middle. That's right. ARP poisoning can become a man in the middle attack. And that is ARP poisoning. And actually in our Pen Test Plus course, we use a tool and we go through and perform ARP poisoning in a lab. So you get to see how that works. So those are virtual switch attacks. All right, let's wrap this up. We're looking at network security groups lastly. And in networking, we create access control lists. And these are basically rules saying who can talk to who. So we might say this subnet here, 168.10.0/24, deny X, Y, or Z, or permit X, Y, or Z. So we're saying who can talk to who, and a lot of times on what type of port. So we're talking TCP and UDP ports. And those are what our access control lists do. We're able to block traffic or permit traffic based on those rules. But where do these go in the cloud? Well, they go to a network security group. In the cloud, we have security groups. And within the security group, we put in our access control lists. There we go. We create these, and we create lots of different security groups. We create some for web servers. We could create some based on a subnet. We could create them for the entire account. The idea is when we need to block or permit network traffic, we're going to do so via a security group. And what's nice about these, they're not only assigned at the network edge. So if we have our virtual network up here in the cloud, it's not just at the edge of the network where we have our connection to the outside. We don't just put them there. We can actually assign them to individual virtual machines if we would like to. So that means you could actually get very, very granular when it comes to your network control rules, your access list, because of the way security groups are deployed. And that has been network and virtualization security. Hopefully you learned something new and are ready to go out there and secure your cloud environment. I hope it's been informative for you. I'd like to thank you for viewing. Let's face it, threats are everywhere. When we have services on premise, we have threats to those services. But when we move to the cloud, well, that opens us up to even more threats. Think about things like account hijacking, insecure APIs. There's lots of things we need to consider when going to the cloud, especially when it comes to the threats. So let's spend some time and talk about some common threats in the cloud. So our first common threat is data loss. Yes, this can happen on premise, but it can also happen in the cloud. And there's really 4 different ways this can happen. This could be an accidental deletion, or data could be overwritten, or we could have some type of data corruption, or we could even have loss of data integrity. All 4 of these examples present us with data loss. So here's the thing that we really need to think about: backups. When we're in the cloud, who's responsible for the backups? That's our first question. Is the CSP responsible for them? Or is the client responsible for them? Well, we need to figure that out, and we need to do so sooner than later. And then, are all the data being backed up, or only some of the data being backed up? Is it being backed up off-site to another DC or data center? Well, it should be. It needs to be in a separate location. And then if we're using something like software as a service, where we're in a multi-tenant environment and an application, can that cloud vendor restore a single client's data? That is a good question to ask, because if you're in a SaaS environment and they're not able to, they have to restore everything. Well, that's going to impact multiple clients. And you know what? You're going to be probably in a bad situation. So we need to think about backups early on before we put any data into the cloud. This needs to be part of our contract negotiation. So that's data loss as a common threat. Let's talk about the next one: data breaches. Now, when we're in the cloud, it kind of changes things because we're dealing with multi-tenancy. If we're dealing with the public cloud, we are sharing the underlying infrastructure with lots of other clients. So, how good is the service provider's isolation? That is very important. If they do not have good isolation, then there's a chance that this client A over here is going to be able to see client C's data, or client B's data, or vice versa. And that would be a really bad thing. That would be a data breach. And if sensitive data is compromised in that breach, well, we're going to have things like public disclosure happening. And if we're in breach of compliance, well, guess what? We might be fined. So fines could be levied. This could turn into a pretty bad situation. And here's the thing to remember: you, as the data owner, are ultimately responsible for that data. So if a data breach happens, and it happens in the cloud, and it was the cloud service provider's fault, that doesn't matter. You, the data owner, are still ultimately responsible because you chose to put the data into that cloud service provider's environment. And even though the cloud service provider might have messed up and there was a breach and it was your data, you are the data owner. You are ultimately responsible. You can point fingers all you want to. It's not going to help. Keep that in mind. Next up, account hijacking. So this is where someone gains access and takes over your cloud account. It's that simple. But how does this happen? Usually it's through credential harvesting. So a lot of times the attacker will send out phishing emails. So these are social engineering attacks, and they're trying to get credentials. Or they're going to be going out and looking to try to find common usernames for your organization. They're going to look at previous breaches, if there were any, so they can find passwords that may have been dumped on the internet by searching things like "have I been pwned?" and trying to find credentials that used to be used in your environment, and they're going to try to gain access to your cloud account and take it over, which is account hijacking. Now, the best way to deal with this is to log. So we're going to say audit log all activities when it comes to the cloud. So especially login attempts, we want to be looking for those, looking for brute force logins. We want to look at logins from new IP addresses. So maybe you see some logins that are coming from another country. Hey, that's probably something you should be looking at. Whenever you see creation of new accounts or you see permission changes, those are things we need to be investigating as well. Yes, they're part of daily activities, but we need to validate them to make sure somebody doesn't have access, maybe low-level access, and they're trying to escalate their privileges so they can perform an account hijack. Next up, insecure APIs. Now, an API, if you're not familiar with it, is an application programming interface. And what it is, it's a way to interact with an application, okay? So an API is a set of rules for communicating with something. And cloud providers, they put these APIs out there so that you can use them to interact with their services. And really what we use APIs for is scripting. So the idea is we can write a script to say, go out and say, hey, how much memory am I using? How much CPU am I using? What's my current bill? All these things. We can collect a bunch of information by using these APIs. And the way that APIs authenticate is by using an API key. And that key is issued to you by the cloud provider. It is your key. It is a unique key, and it's your way to authenticate. So we don't want to let these API keys get out there, right? We need to protect them just like a password. So keep those private. Next up, denial of service attacks. So, of course, denial of service, it's when attackers go out and attack something like a server that's running services, right? So an attacker goes out here and tries to use up a bunch of resources so that the server can no longer do its job. So how do we prevent denial of service attacks from happening to our cloud services? Well, number one, we need to reduce any single point of failure. So that's the first thing we need to do to make sure we don't have single points of failure and we have alleviated that risk. Next thing we need to do is patch. We need to patch our systems, patch our firmware, make sure all of our patches are updated, because some denial of service attacks are only good against certain types of vulnerabilities. And if we patch our systems, hopefully we won't have those vulnerabilities. Number three, use some type of rate limiting. And oftentimes your CSPs, your cloud service providers out there, are going to have something that you can do to rate limit. And when I'm talking about rate limiting, what it is to limit the number of connections from a certain IP address. So you could say only allow 5 connections per minute or 50 connections per minute from any given IP address, and it'll just keep track of that. And this way you can limit the number of connections and you can prevent denial of service attacks. Now this might mean that you have to deploy your own firewall or intrusion prevention system in the cloud and do it that way. But hey, that is one way to do it. You need something to rate limit. And then lastly, an option is to subscribe to a denial of service. And kind of a little redundant there, denial of service. But the idea is these services protect against denial of service. And the way they work is generally you will have a denial of service protection provider that sits out here in the cloud. And what you do is you point your DNS records for your servers to the denial of service provider. And then they act as a proxy to gain access to your servers. So the rest of the world has to go through them to get to your servers. That way they can filter out and protect you from denial of service attacks. So that is a fourth option. All right, a couple more to go. Next one up, cloud service abuse. That sounds interesting. Well, that's because attackers, those bad guys out there, they can actually use cloud services. And what they can do is they sign up for an account, they spin up a virtual machine out there, they load their malware or their attack software on it, and they go out and they attack. Well, how can we prevent that? Well, we really can't. But you need to be aware of this. And cloud service providers, those CSPs are always watching for this. And then what do? Well, they shut them down. They take care of it pretty quickly. However, you just need to be aware that that is an additional threat. Next up, malicious insiders. Now, these are folks who were insiders. Maybe they're previous employees, current employees. They could be contractors, but usually they feel like they've been done wrong or mistreated. And that is what gave them the incentive or the motivation to become a malicious insider. They felt they've been done wrong and they want revenge. So how do we protect against this? Well, it comes back to our identity and access management. Remember, part of that was deprovisioning accounts and access. We need to make sure that we do this properly and that we remove all access. Don't leave any holes left for somebody who left to get back in. And lastly, common threats, insufficient due diligence and due care. Now we're going to talk about due diligence and due care and really what they mean. So let's start with due diligence. Due diligence is the process of understanding something. And part of that understanding is identifying the risks associated with whatever that is. So if an organization down here has an on-premise setup and they want to move to the cloud, so they go and set up a cloud account and they move all their stuff to the cloud, and they start having all kinds of problems. They're having breaches, they're having services go down, they're having all kinds of bad problems with customers and such. Well, guess what? Maybe they didn't do their due diligence. They didn't go out there and take the time to understand what moving to the cloud meant. They didn't take the time to train their employees so that they would know how to manage a cloud environment. And that's what due diligence is all about. Taking the time to understand something and all the risks associated with it, really wrapping your head around it. And then the next part is due care. And that's where we take this understanding and we put it into action. And generally that happens via policies and procedures. Because once we understand something, then, and at that point, we can create policies and procedures and put them into action. So we've taken action to reduce the risk. And this is all about risk. It's about addressing risk. And when we're talking about the cloud, this is new for a lot of people and organizations. They really need to practice due diligence to understand what going to the cloud means financially as well as security-wise, looking at risks associated with it. Moving data. Do we have sensitive data? Should it go to the cloud? Should it not go to the cloud? Do I have compliance requirements that need to be met? And can they be met in a certain cloud provider? That's all part of due diligence. And then once we decide, okay, we can address the risk of moving to the cloud, at that point it moves into due care and putting these things into action. And that's why insufficient due diligence and due care is a common threat. If we don't do the proper research ahead of time and we jump into something like the cloud without understanding the implications and taking the time to do it right, well, then that could bite us in the rear and be really, really bad. And those have been some common threats in the cloud. I hope this has been informative for you, and I'd like to thank you for viewing. Let's talk about your vehicle for a moment. Now, when you get a new vehicle, new to you, you go out and you purchase it, right? And you take ownership of your vehicle. And then throughout its lifetime, you're going to be paying taxes on it, getting insurance for it, renewing your insurance. You might loan your vehicle out to someone. You're going to be taking your vehicle in to have maintenance done on it. If something's wrong with it, you might do the maintenance yourself. Doesn't matter. But the idea is once it is no longer useful to you, at that point you're going to sell it off or trade it or donate it or something like that. And that entire process really is a life cycle of your vehicle. Well, when it comes to data, well, it has a life cycle as well. From the introduction of the data to where we create the data till we no longer need the data. What do we do with it at that point? Well, that is the data life cycle. And when it comes to cloud, we really need to understand that life cycle so we can make sure that we accurately protect that data throughout its entire life cycle. So let's jump in and talk about data life cycle in the cloud. So I've got a question for you. We're going to start off with the question, what is the cloud? Now, we've talked about different services in the cloud and different subscriptions and models that we use in the cloud, but let's just stop and talk about what is the cloud. And I'm talking like, in general, what is the cloud? That's a good question. And really the answer is, it is someone else's infrastructure. So we have our own data. This is our data that we create over here. And this is very important to us. This is our assets that we're talking about. Our data we need to protect. And the idea is if we're using the cloud, which is someone else's infrastructure, that means we're going to be taking our data over here and we're going to be moving it into somebody else's infrastructure. And they're managing the infrastructure itself, but that means that we still manage our data when it's in someone else's environment in the cloud. And this means we really need to know where that data is at all times. And I don't mean where as in what cloud vendor, I mean where as in physically. So here we're talking about the geography of where our data is located. What country is it in? And that's important to us, especially when we're dealing with sensitive data and we have compliance and regulations to deal with. We really need to know where our data is at all times. And this is part of, you guessed it, our cloud secure data lifecycle. So now let's jump over and take a look at that lifecycle. So here we go. This is our data lifecycle in the cloud in progress. Well, we start off with creation. So we create our data because we have to create it or we have nothing to have a lifecycle, right? If we don't create it, we don't have data. And once we've created the data, we now have something. We have data. So what's the first step that we do with data? Well, we need to store it somewhere. And it's very important that we understand where it is being stored. As I mentioned, physically, where is it? What country is it in? Where is it? What cloud vendor is it under? Or are we keeping it on premise? We need to know where that data is. And once we store that data somewhere, well, here's another question. Are we going to encrypt the data that we're storing? If it's sensitive information, there's a good chance that we're going to be encrypting it. And again, that is part of the storage process. And once we store it and our data has a home, well, then we can actually start to use our data. So here is where we're going to run into access control, absolutely, and our logging, because when we're using the data, we have to provide some type of control over the access so we can ensure that only authorized users can access and use the data. And then we want to log all activity associated with the use. Who's using what files? Who's accessing it? Who's editing files? Who's using applications that use our data? All of those things are things that we should know while we're managing our data. And at some point, we might decide to go ahead and share out our data. And again, this is where access control over here that we use during use actually shuffles down here to share, because we need to provide some way to authenticate users who we share our data with so we can ensure that that data is only accessed by authorized users. And then the encryption we talked about up here in store, it actually comes down here to sharing as well. Because when we talked about data in transit, well, if we're sharing it, we're probably emailing it or we're doing some type of data transfer. That data is transiting across an untrusted network. So, well, we need a way to protect it, and encryption did that. We talked about using TLS encryption, transport layer security. We talked about using IPsec. So that was our TLS, and our IPsec we talked about with encryption. Those are valid ways to authenticate data in transit. And then once we've shared it out, and this is all kind of part of the use cycle, our using and sharing, at some point we're not going to need to use it anymore, but we can't really get rid of it just yet. So we need to discuss archiving, because that's what we're going to do with the data. Until we can destroy the data, we need to archive it. For instance, if we're under some type of compliance that says we have to retain data for, let's say, 7 years, well, guess what? If we only use it for 1 year, then I have to archive it, well, for 6 years until I can destroy it. And this archiving process is very important. So once we go from sharing, we go over here to archiving. We're going to archive that data until its life cycle has ended and we can destroy it. But until then, it's going to be archived. And here's a question: where are we going to archive it? That's a very good question. We have to physically know where it is. And when it comes to the cloud, there are certain types of storage that are mainly used for archival. And we're going to talk about those later on. But they have special types of storage areas that are much cheaper to use to archive data. So now that we have that data archived, it's sitting in there, we're not using it really, it's archived, but we're waiting for its life cycle to end. So once it does, well, then we end up at the destroy phase. And here's where we're going to properly sanitize or destroy our data. And in the cloud, there was one specific way to destroy data that we said was the best option. Do you remember what it is? It was cryptographic erasure, or crypto shredding. And there you go. Once we crypto shred our cloud data during the destruction phase, hey, we're done. That is the data life cycle. But you know what happens next? That's right. We create more data. That's a never-ending process. We're always creating more data. and then that data goes through its life cycle. So that has been the Cloud Secure Data Life Cycle. I hope it's been informative for you, and I'd like to thank you for viewing. All right, we're going to talk about your vehicle one more time. Okay, so here we go. You've got your vehicle out there, and in order to use it, right, certain things have to happen, right? We've got to make sure there's gas in it. Yeah, that would be pretty helpful. And we have to make sure that maintenance is done to it so it continues to operate properly. We'll probably need to make sure that only authorized users or authorized drivers can use the vehicle. We don't want just anybody using it. There's lots of different things that go into the management of the ownership of your vehicle to make sure that you are able to use it when you need to. Well, the same thing is true for data. We need to own this data. We need to make sure certain things happen. We need to classify the data. We need to make sure it's being taken care of on a day-to-day basis. And all of this effort is known as data governance. So let's jump in and discuss data governance a little more in depth. So what is data governance? Well, as I talked about, it's really all the things that go into making sure your data is properly managed. So it's the practice of evaluating the requirements of the data and providing direction and control over that data so that the users accessing the data can have trust in the data. Make sure it's accurate and it's complete. And that really is a big part of data governance. Without data governance, we really wouldn't be able to trust our data. And if you can't trust your data, then what good is it, right? If we can't trust that our inventory is correct, well, then we could have some serious problems. If we can't trust that the data showing that we have shipments coming in from distributors and from suppliers, well, then we could be in deep trouble as an organization. So trust is paramount when it comes to your data. If you can't trust it, well, then it's not very useful. Another important part of data governance is knowing what data you have. Because if you don't know what data you have, then how do you know it's being protected adequately? Because just like this, if you didn't know you owned a vehicle, well, then it wouldn't be taken care of. So we need to know what data we own. We also need to know where that data is that we do own. Because if you don't know where your data is, then how are you going to know if it's affected by a breach or maybe a natural disaster? And how are you going to know how to restore it from backups if you don't even know where it was located? You could be in serious trouble. So data governance, you really need to know what data you have so you can govern it, and of course, where it's located. Now, with that being said, let's discuss something else. Data governance and the cloud. Why is data governance imperative to the cloud? Well, here's why. I'm going to put that where up here again, where your data is. Now, here's the thing. If we're dealing on-premise, then hey, I know it's on-premise. It's on one of my servers. That's good, right? And I need to know exactly what server my data resides on. But when we're dealing with the cloud out there, remember, this is a global cloud. We need to know exactly where that data is located geographically. That is very important to us. And it really comes down to knowing what legal and compliance requirements we have and whether or not those have geographical implications. Now, if you don't have to worry about those, you still need to know where it is. For example, if there is, I don't know, let's say civil unrest in a country where your data is residing and there's riots and there's all kinds of things going on, do you think you want your data residing in a data center in that country where you might experience power problems because of things going on in the region? Well, you might want to think about migrating that to a different location. All right, now it's time to discuss some of the activities associated with data governance. And we're starting off with data classification. And just like you see in the movies, where you see the documents in the military being handed from one person to another, and they're marked top secret or confidential or something. Well, that, of course, yes, that is data classification. But it's more than that. And we could use lots of different words to describe it. Maybe we'll say confidential, or maybe it'll say internal only, or secret, or maybe even public. But those are words to describe the classification of specific data. But here's the question: why? Why do we do this? Now, let's think about this. So if I have a document here, maybe I've given a bunch of documents. Let's say I'm given these documents right here, and I have them in my possession. And you know what? It would be great if I could maybe release this document to the public so that they could understand what we're doing, what our goals are, and so on and so forth. Or I'd like to share this document over here with a business partner because I think it might be beneficial to them. Well, can I do that? Well, I don't know. Well, how could I know for a fact that I can or cannot do that? Aha, here we go. Here's where we're getting to our classifications. If I classify my documents, I take these keywords over here and I assign them to a document, then I understand how I'm able to manage that document. What can I do with that document? Can I share it out or can I not share it out? Now, these labels that we have down here, public, secret, internal only, confidential, whatever we come up with, they are simply a label. They don't really tell us how to do something, right? They're just a label. So what tells us how to treat these documents with these labels? Well, that's where our policies come into play. We're going to have a data handling policy that's going to tell us how to handle each one of these labels. So we might say that our public data can be released to the public. And this is going to be things like marketing material. Of course, that's stuff that we want to go out to the public. But it may say that confidential data can't leave the organization, can't leave the building unless you have written approval, and then it must be encrypted in transit. That's what a policy will declare. It's going to tell you exactly how to handle each one of these classification labels. And then we apply the labels to the documents over here. And then everyone in the organization knows exactly what they can and cannot do with these documents. And that is the real purpose of data classification. Next up, authorization. So we've talked about authorization before, and really it comes down to who has permissions to what data. And a lot of times this could be based on classifications, or it could be based on your job title or role, but it could be based on lots of different things. But the idea is we need some type of authorization in place that's making sure only authorized users can access data. And that's what authorization is all about. And along with authorization, we're going to have some type of logging that is logging the activity of the users, whether it's authorized or where people are trying to access data in an unauthorized fashion. That's a good part of data governance. And next up, custodianship. Now, custodianship is the role that's associated with the day-to-day management of the data. So we have the data owner who actually creates the data and assigns a classification label and defines who is authorized to access the data, but that is just the data owner. Usually it's someone else who's going to manage the day-to-day activities supporting data, and that's generally the IT department. And that role is known as a custodian. So the data custodian manages the day-to-day activity of supporting our data. And last up, location and jurisdictional policies. So here we're talking about policies again, and we're talking about jurisdiction and location. Now, I've said it's very important we understand where our data is physically located. Well, we talked about a data handling policy, didn't we? We sure did. Well, that policy should also outline the location and or jurisdiction of certain types of data. For example, maybe we say that secret data cannot leave premises, so it's got to stay on premise. Well, that means that we cannot take secret data and send it to the cloud. That's just not going to be permitted because of our data handling policies. Hey, and that's great, that's fine. The idea is we really have to have these policies or we're going to be in trouble because there's no telling what's going to happen with our data, who's going to send it where, and we won't know where it's at. So we'll need in these policies what locations can our data be stored at. And specifically, we're going to say on-premise or off-premise. And we're going to include what countries it cannot be a part of. We're not going to necessarily list all the countries that we can send data to, but if there is some legal or compliance related reason that we can't have data in certain countries, then we're going to put those as a no-go country, right? So that is the location. But we're also going to have jurisdictional policies. And the jurisdiction is dealing with the legal oversight. Because when our data resides in a foreign country, well, believe it or not, it falls under the law of that country. And that's where our jurisdiction comes into our legal oversight. So there are certain countries we might not want data in based on our jurisdictional requirements. So again, it goes back to location. So there we go. Those are location and jurisdictional policies. And again, we're talking about where our data is located. And that covers data governance specifically in the cloud. I hope this has been informative for you. I'd like to thank you for viewing. A few years back, where we live, we had a pretty bad ice storm and we were out of power for a few days. Now, as you can imagine, that did provide some challenges. We needed to try to stay warm, so we got out extra blankets. We fired up the gas logs in the fireplace. And then our freezer goods we actually put outside because it was colder outside than it was in our freezer. So those are some different things we did to overcome the challenges of not having power during an ice storm. Well, in business, we have to overcome natural disaster challenges as well as business challenges as well. So that means it's time for us to jump in and talk about disaster recovery and business continuity in the cloud. So we're starting off with disaster recovery. Now, disaster recovery's goal is to quickly restore services. And generally, this focuses on IT services. And that being said, not all services are equal when it comes to disaster recovery, right? I'm sure you could imagine. You think about all those different IT services that we have, and you can see that when we're examining them, some of these services out here are more important than others. So what we have to do is something called a business impact analysis, a BIA. And this business impact analysis is going to help us to determine which of these services over here is most critical. And that way we can prioritize those services into a new list of IT services, and we can rank their criticality so that we know when there is a disaster, we really need to focus on the services at the top first, because those are most important to our business success. And that's what disaster recovery is all about. It really focuses on quickly restoring IT services, and we use a business impact analysis to figure out what services need to be restored first, which ones have a higher priority to the business. Next up, business continuity. Now, disaster recovery focuses on IT services. Business continuity does not. It focuses on the business itself and business related events. And these events could be something like the loss of the CEO or the CFO or the CIO. I don't know. It doesn't matter. It could be lots of people, could be one person, but somebody in a key role. If you have a loss of one of those persons, well, it will impact the business. And we need to have a plan around what to do if that happens. But that's not the only thing. There's lots of things we include in a business continuity plan. Another one could be like loss of a major supplier or vendor, because that would have a serious impact on the organization and its continued success. And it could be lots of different things. It could be some type of legal problem that comes about, and we just need to have plans for this. So that's what the business continuity is about. It's about making sure that the business can survive, and it focuses on business related events. And a lot of times we combine these two together into one, and we refer to it as BCDR, business continuity, disaster recovery, handshake, we're all on the same team here, right? And the goal is to get back up and running, whether it be an IT related service that's down or some type of business event that happens and we need to recover from. Either one of these, we're really focusing on working as a team to get back up and running as soon as possible. Now, when it comes to the cloud, it is very important that we understand who's responsible for what when it comes to BCDR activities. And that's because we have the customer that is involved in this relationship as well as a cloud service provider. And we are going to have responsibilities that fall on the customer and some that fall on the CSP. And we really need to know and have it documented who's responsible for what. And we also need to understand if maybe there is another third-party vendor that's involved, because maybe the CSP relies on this vendor for some type of service. Well, we need to know that so we can have it documented. We also need to define an order of restoration. And remember, we talked about doing a business impact analysis to identify what services are most important to the business. And that helps us to provide prioritization so that we can come up with an order of restoration. Something else we want to consider is including a right to audit in our cloud contract. And that gives us, the client, the right to audit the CSP. And things we'll be checking for is to make sure that they have the proper documentation in place, they have procedures in place so that if something was to happen, that they have everything in place to properly respond to the incident. And then we need to define a communications process so that if there is an event, we have documented the persons who the CSP will contact. They'll have a list of people to contact if there is some type of event that's going on so that we can figure out what exactly is going on and we can properly communicate that inside the organization once we find out from the CSP. And lastly, we're going to talk about backups. And backups are super important. And the idea is when we have data in the cloud, we don't want to back up our data to that same location. We want to make sure that our data is backed up in another physical location. And actually, it would be a good idea to also probably back up to a different vendor. Or maybe you back up on premise. So your cloud data actually gets backed up on premise. The idea is you want to have your backups in a separate location and a separate trusted location. And really, honestly, I would do it on premise and or at another vendor. Because if you have a fallout with your cloud vendor or they go out of business and close their doors without notice, well, you would be in a vendor lockout situation. That's something we definitely want to avoid. So really consider backing up to a different cloud vendor or backing up on premise. All right, next up, it's time to talk about service level agreements or SLAs. Now, first off, let's define what an SLA is. An SLA's purpose is to define what level of service a customer should expect to receive from its vendor. Now, it depends on what vendor it is, what this is going to include. But if we're talking about cloud vendors, well, we could talk about bandwidth. How much bandwidth am I guaranteed to receive? Accessing my data in the cloud and backing it up maybe. What are the time requirements for performing certain actions? So we have time requirements. And maybe it's restoring data from a backup. If they manage part of your backups and you need data restored within an X amount of hours, well, that needs to be documented in the SLA so you know that will be met. We also need communication requirements. And these communication requirements, so if there's a problem, maybe they have to notify you within 15 minutes. Or if there's a data breach in their organization, they have to notify you within, 2 hours or 6 hours, whatever it might be. But you need to come up with your communication requirements and make sure that they are included in your service level agreement. Now, that service level agreement is very important. And you're going to want to work with your provider to make sure all of the things that you think are important as an organization are listed in your SLA and are addressed. Now that we're talking about SLAs, let's combine the two, SLAs and BCDR. So what are some requirements that we should have in the SLA that service our BCDR activities? Well, that's a good question. Well, let's start with clearly defining what the responsibilities are. And specifically, the cloud service provider's responsibilities here. And along with those responsibilities, there's going to probably be some type of timeline associated with it. So if they're supposed to restore data from a backup, well, they need to do that within 1 hour. And this, of course, is going to have to be agreeable with the cloud service provider. You can't just demand something that is unreasonable, right? You're going to kind of work together to define what these are. And as far as backups and stuff, you're going to discuss and outline your RTO and your RPO. And your RTO is your recovery time objective. And this is a time-based goal to restore services. So if, for example, your cloud services were down, well, you need them back up within 2 hours. So your RTO, or your recovery time objective, is 2 hours. You need to get back up and running in 2 hours. Well, that needs to be agreed upon and documented within your service level agreement. Now, your RPO is different. This is your recovery point objective. And this is actually a data loss goal. And goal, you say, well, I don't want to lose any data. Well, in a perfect world, you wouldn't. However, what is acceptable? What amount of data could be lost in an acceptable situation? And here's where I'm going with this. When you're talking about an RPO, our recovery point objective, it's a point in time. So if you're running your backups every 2 hours, and 1 hour and 59 minutes after your last backup, everything goes dark, and you're not going to be able to recover any of that data since the last backup. Well, basically you lost 1 hour and 59 minutes worth of data. So roughly 2 hours. And if that's acceptable, then you can have an RPO of 2 hours, because your data loss goal, or is what's acceptable really, is what we're referencing here. And it comes down to how often your backups run. Now, if you can't lose any data at all, then you need to look at using some type of a continuous backup solution. And they're out there. They're very expensive, but they're out there. But if you have less of a budget, then you need to figure out what can we lose in data and still be okay. And by lose, I mean time-based metrics. If I can lose 2 hours worth of data and still be okay, then I can use a backup solution that runs every 2 hours. So we need to talk about these two items. That's our recovery time objective and our recovery point objective with our internal team, so we can identify what is acceptable here. And then we take those numbers, we take them to our cloud vendor to get them put in the SLA. So those are two very important things, our RTO and RPO, when it comes to BCDR activities. Something else that might be included in our SLA is penalties. What happens when our SLAs are not met by our cloud vendor? Well, then there could be penalties involved, and that's to hold them accountable. And then lastly, we need to determine some type of communication requirements. And we mentioned this earlier. It's really important that communications happens. We have to say, if X happens, I need to be notified within 15 minutes. Or if Y happens, I need to be notified within 1 hour. And along those lines, these are the people who need to be communicated with, and they need to be called. We only accept phone calls. We do not accept emails or text as a type of notification. We need phone calls, and then you provide them with a phone tree. So you need to define what your communication requirements are, how they will be met, and you include those in your SLA. All right, let's talk about a couple of other SLA components that are very important. Number one is activity timelines. Now, these are activities that you would request that your cloud provider do. It could be things like exporting data or restoring backups or doing lots of things. Help maybe importing of a server image or something like that. And these are things that are important to your organization. You need to define timelines around those activities, and you need to get them put into your SLA so that you can have them met appropriately. Now, an example of this might be data exports, because maybe you want to move from one CSP to another, and in that instance, you need your data exported, and it needs to be done in a timely fashion. So you would say, maybe I need data exports to happen within 12 hours. Or maybe 24 hours or something like that. But you need to define that number based on your organization needs. Something else that should be documented in your SLA are any single points of failure. So if your CSP has single points of failure, they need to be documented in the SLA so that you know about them. So, what good does that do you? Well, here's what it does it allows you, the customer, to see those single points of failure that exist, and then you can understand the risk associated with those single points of failure, and you might be able to do something, put some type of control in place to address or minimize that risk so that that single point of failure isn't quite as risky as it originally was. Something else that we need to have is an automated way to validate data integrity. Now, oftentimes this is done through error checking or error validating, but you need to have a way to automatically validate your data's integrity. And a lot of cloud providers have a way to do this. Basically, it's like an error checking mechanism, but you need to have that and defined in your SLA that you can use it, because oftentimes there might be additional costs associated with it. Maybe you'll get it worked into the contract, so there is not. And then lastly, other components and things you should think about when it comes to SLA is regular reviews of the SLA. Because our environments change, our needs change as an organization. So sitting down and reviewing the SLA every year would be a really good thing to ensure that they continue to meet your organizational needs. And the last point I want to get across is make sure that you are fully satisfied before you sign any of your cloud contracts, including your SLAs. And this is very important because if you've got your contract and your SLA and all these things documented out here, and you go and you sign it, well, guess what? That is what it is. If you want to make changes to this, well, it's probably going to cost money. Because once this is set in stone, until you do some type of agreed upon review, it is what it is. And if you want to make changes, well, there's probably going to be some type of financial penalty. So keep that in mind. Make sure you are fully satisfied with your arrangements before you put ink on paper. And that has been business continuity and disaster recovery and SLAs in the cloud. I hope it's been informative for you. I'd like to thank you for viewing. Here's the question I get a lot. Is cloud really cheaper than on-premise? Well, the answer, it varies. And that's because different environments, well, they're different, right? Because the cloud provides us some great features that we might not have on-premise. So we kind of have apples and oranges at that point. But even if we did have apples to apples comparison, what is it worth to your organization to be in the cloud? Is there a true cost benefit? Well, that's a great question, and that's what we're going to talk about right now with cost benefit analysis. So the first question we have, is cost a factor? Come on, folks, we know that the answer is an astounding heck yeah, it is. Cost is always a factor in our decisions. Now, if it wasn't, it would be great. We could do whatever's best for the organization, whatever features are best for us, but we do have limitations, and those limitations are generally financial limitations. So, cost is almost always a key data point in deciding whether or not to go to the cloud. With that being said, let's talk about some points to consider. Now, some of those points are, when we are in the cloud, we do get to take advantage of resource pooling, which means there's a ton of resources out there and we can access it whenever we want to. We don't have to go and buy additional CPUs, buy more memory, buy more storage, and go and configure it and wait for it to be delivered. No, that stuff is all at our fingertips. And a great benefit to the cloud service providers is when they purchase these large amounts of resources and pool them, then they can offer us more attractive pricing compared to as if we were to do it ourselves. So oftentimes there is some money to be saved there. Another point is factors in efficiencies. Cloud is simply easier to manage than on-premise infrastructure because the CSP is taking care of a lot of that work, like they manage the underlying hypervisors. They manage the physical servers and the physical networks infrastructure, not to mention all that storage infrastructure as well. They manage all of that for us. We just carve a little piece out and use it. We just have to worry about the management of our services, not the underlying hardware and physical infrastructure. So, of course, this includes a serious reduction in our maintenance requirements as far as labor. And this allows for a shift in focus so that we can take all that focus we had on managing our underlying physical infrastructure and we can focus that on new activities that are going to benefit the organization. All right, let's talk about a couple more points to consider. We're continuing with our points that we need to consider when we're performing a cost-benefit analysis in the cloud. Well, one of them is a shift from CapEx to OpEx. And remember, we talked about these earlier, where CapEx is where we had a large upfront financial investment in creating our infrastructure. We had to go out and buy all of our infrastructure and spend all that money up front. Whereas OpEx is a month-to-month financial investment that we're making, and we can work that into our expenses. And we can easily forecast what our needs are and what our expenses are going to be. And that's a key point here. With this shift to the cloud, it allows us to do some great financial forecasting as to what our needs are going to be and what our financial expenses are going to be in the cloud. Next up, depreciation. Now, when we use CapEx and we go out and buy all of that hardware on our own and we've got it sitting on premise, well, yeah, what we're going to be able to do is use depreciation to our benefit. Depreciation is going to go to our books on an annual schedule so that we're writing off our depreciation as an expense. Now, when we shift to an OpEx, well, we don't have depreciation to use, so that's something to keep in mind. Another point, utility costs. So here we're talking about if we have servers and infrastructure on premise, well, we have to power all of that, and then we have to cool all of that as well, because as we use that power to make sure our infrastructure is running, it's going to create a bunch of heat, and we have to cool all that heat. We've got to get rid of it. So along with this, well, that is our utility cost. So that's a cost that will greatly diminish if you go to the cloud, because you don't have that infrastructure on premise that you're powering and keeping cool. All right, a couple more points to consider. Number one, reduce software licensing cost. Because if we have a physical infrastructure on site, we purchase servers, then we're going to have to, of course, purchase licenses for those servers and most likely pay an annual licensing fee to go along with it. Whereas if we're in the cloud, the CSPs are able to purchase such large volumes of licenses that they can in turn save us quite a bit of money on our software licensing. And then lastly, in the cloud, we are in a metered cost infrastructure, which of course means we only pay for what we use. Whereas if we purchase a server infrastructure and we put on site, we've got all these servers that we purchased for on premise, and if we're only using 40% of their capabilities or their resources, we're still paying for 100% of it. Whereas in the cloud, we only pay for what we use. So it is very cost effective. And those are some really great points to consider when you're talking about cost benefit analysis and you're comparing your on-prem to a cloud solution and you're trying to calculate and come out with what is the true cost here. And that leads us to considering some data points for TCO, or total cost of ownership. The first point I'm going to talk about is legal costs. Because when you move to the cloud and start using cloud services, you're going to want someone from legal or a legal representative to review those contracts and make sure that they are in your organization's best interest. Now, if you're not using cloud services, you probably don't have this expense. So this is something that actually is less on premise. And that carries over into contract negotiation, because you're going to be performing negotiations with your cloud service provider, and that's going to take up time from most likely your C-suite. And at that point, well, that's additional time they have to put into that, plus legal is going to be reviewing those additional contracts. And what about training needs? If you're not using cloud services, then your on-prem IT support team, well, they probably don't know how to support a cloud environment. So, well, we're going to have to either hire some folks who do or train our internal folks if they're willing. And either way, it's going to cost us some money. And next up is reporting capabilities. And this usually comes down to logging abilities. And if we have some complicated reporting capabilities that we need, well, can the CSP meet those needs? That's the question here. And most oftentimes they can. However, it does come at an additional expense. They offer additional logging and analysis services, but again, you're paying for those. Those aren't part of the base package. And then lastly, I'm going to put that right down here underneath because it's very related, audit capabilities. And again, logging comes into this because we're going to be auditing the data in those logs. Is there an easy way to do that with this cloud provider? Do they offer some type of auditing system for your logs? And oftentimes they do. However, again, you're paying extra for that. So those are some things we need to consider when we're talking about total cost of ownership and cost benefit analysis in the cloud. So we're comparing our on-prem to a cloud solution. Which one will win out in the end? Well, I don't know. It's up to the results from our cost benefit analysis and TCO analysis. I hope this has been informative for you. I'd like to thank you for viewing. So I've got a question for you. What allows you to be successful at your job? Well, is it training so that you understand how to do your job, maybe additional and ongoing training? Or is it communication so that you know what's expected of you as part of your job? Or maybe it is a good family life work balance so that you're mentally stable and you're ready to rock and roll every day and totally full of energy. Well, all of those things are requirements that allow you to function in your job and to do your job effectively. So those are functional requirements of your job. Well, guess what? Organizations have functional requirements as well. Of course, in order for an organization to be successful and reach its goals, it's got to have some functional requirements. So let's jump in and talk about functional requirements and the cloud. So what are functional requirements? Well, we just talked about that. And those are any services required for an organization to achieve its goals. And it's pretty important that we define these requirements before we can answer the question, do cloud services meet our functional requirements? So first we have to define what are our functional requirements. So let's talk about some of these. The first one is interoperability. Do we require interoperability? And this is the ability for multiple systems to work together. And this does include cloud services. So we see folks working together down here. So here we're talking about systems working together. And do we require that? Well, if we do, then there's some best practices that we need to follow to preserve interoperability. And one of those very important best practices are to avoid proprietary formatting and technologies. That is very important. We want to make sure that when we are working with cloud services that we avoid any proprietary formatting and or proprietary technologies, because if we don't, if we allow cloud vendors to use proprietary formatting and technologies with our data, well, then it can make it difficult to export that data in the event that we would need to leave a cloud service provider. So if they export that data and it's in some type of proprietary format, when we try to import it into another cloud service provider or even into an on-premise setup, well, guess what? It's not going to work. And we're going to be, in a bad situation. So if we require interoperability, and really it just comes down to best practice overall, if you can, avoid proprietary formatting and technologies. Next up is portability. So portability is moving data from one application or environment to another. right? So if we've got app A or data center A and we're moving it over to data center B or application B, well, we're porting that data. And in order to port that data successfully, we want to make sure we have favorable contract terms for moving between CSPs. So really, in this instance, we need some type of out. So if the cloud service provider is not meeting our needs, they're not meeting SLAs, they're not delivering, then we need some type of out in that contract so that we can get out of it and we can move to a cloud service provider that will provide us the service that we need. And along those lines is if we're going to leave a CSP, we need some type of exit strategy. That is very important. We need a plan so that if we do need to exit, well, we already have a plan. We don't have to run around like a bunch of crazy people trying to figure it out at the last minute. We need to have this ahead of time. And then again, lastly, we want to avoid, you guessed it, proprietary formatting and technology, because these can lead to vendor lock-in. And that's the next slide. So what is vendor lock-in? Well, it's definitely not a good thing. This is when a customer is unable to exit a vendor. So then you're stuck with that vendor. And if they're not meeting your needs and they're not allowing your organization to succeed and thrive and meet its goals, well, guess what? That is a bad situation. And we want to avoid that. So how do we avoid that? Well, a lot of the things we just talked about: portability, interoperability, making sure that those are there. We need to make sure that our SLAs are defined and we have favorable contractual agreements that allow us to leave an SLA. And again, we've got to avoid the proprietary formats and technologies because those can lead to vendor lock-in. And that's something we definitely must avoid. And those are some functional requirements of an organization, and specifically as we consider moving to the cloud. I hope this has been informative for you, and I'd like to thank you for viewing. Now we've talked about the three different categories of cloud services. We've got infrastructure as a service, platform as a service, and software as a service, but we haven't talked a whole lot about like security practices in each of them. And are they all the same? Do they have different requirements? Well, that's what we're going to talk about right now. We're going to look at some security practices specific to each of the three cloud categories. So let's get started. We're starting off with infrastructure as a service. And so remember, this is where we're deploying instances or virtual machines. We're accessing our storage here. We're building out virtual networks, setting up security controls within them. So let's talk about some security items that we want to consider with infrastructure as a service. Well, number one, we want to control network access. And we've talked about this before, and we do this through the use of security groups. Security groups are where we create our access control lists that are defining what subnets or networks can talk to what other networks and hosts on what ports. So this is controlling network access with security groups. We also want to use redundant technologies. And these are things like failover between data centers, where they will allow us to recover from a security incident if it happens. So really we want to focus on using redundant technologies. And I say this because most cloud vendors, when you set up a new VM instance, well, it's not replicating that data to another identical setup like you have created in your primary cloud vendor. So you may have to go in and say, this is my primary virtual network in the cloud. This is my primary, and I want to set up a secondary one where everything replicates between it. Well, this usually isn't done by default. You have to set this up. So consider using redundant technologies. The next thing I want to talk about is monitoring. We need to monitor our servers and devices and patching and vulnerabilities in the cloud just like we would on premise. So here's what we're doing. Basically, we're monitoring for like up down of our devices to make sure that they're up and running and available. But we also want to monitor our OSs, and our patching, and our application patching to make sure that we're keeping our applications and operating systems that we have running in the cloud, make sure we keep them up to date and keep them secure. And this here leads into our fourth point: patching, patching, and more patching. Remember, when you deploy instances or virtual machines in the cloud, we are responsible as the customer for everything in this virtual machine. That means the operating system that's running on it, any applications that are running on it, we're responsible for that. So we need to be patching these. If we load some type of virtual network appliance, maybe we deploy an intrusion prevention system or a firewall of some sort, we are responsible for keeping these up to date. And we need to do that because this is infrastructure as a service. We're responsible for what's inside of those devices we create. Now let's take a look at platform as a service. And remember, platform as a service is a platform that the service provider provides you with to build applications on. I said this was a lot like using Legos. They provide you with a platform with all these great widgets on it and features, and you get to kind of stack them and build as you see fit to create whatever you'd like to. Now, here's the thing. We need to concentrate when we're talking about platform as a service is isolation of resources. And that's because these are multi-tenant environments. So there are several customers on the same platform. So we really need to make sure that the cloud provider is addressing isolation, which 99% of the time they are. Next up, access control. We saw this in infrastructure as a service where we use security groups as part of our access control, where here we're building our own application. Well, we need to make sure when we're building our applications that we include access control to keep unauthorized users out. Next up, secure coding practices. As we're using this platform to develop these new applications, we really need to focus on using secure coding practices, because if we use insecure practices, we don't use access control, we don't use any type of authorization, well, you know what? We are building an insecure application. It's not the vendor's fault. They provide a great platform. It's our own fault. So us as a customer, we really need to focus on using secure coding practices. Then we want to, perform some additional monitoring. Just like we did with infrastructure as a service, we need to monitor some things. We want to monitor the availability of our application. We want to monitor the security of our application. We want to do some security testing against it. And we want to monitor some auditing. So here we're monitoring the logs by doing log audits. We're monitoring the availability, make sure our application's up and running and that the vendor is meeting their SLAs. And then lastly, we want to build in some security to protect against common attacks. And if you want to look at some common attacks, go out there and Google the OWASP Top 10, and that deals with web application security and the top 10 most common types of attacks against them. So what we want to do is make sure that we're protecting against those attacks, like malware upload and injection attacks and security misconfigurations. These are all things that we need to be aware of as far as security and platform as a service. And then lastly, software as a service, or SaaS. Now there's three things we really want to take a look at here. The first one is, you guessed it, access control. And we've seen access control against all three of these now, because we definitely need to do that. Now here, this is a software that we're using. The vendor is providing us with some software to use. Well, it's up to us to define what users exist on that software. So we have to create our users within the software, and then we have to define authorization. Because there's definitely the possibility that not every user of this application needs access to all of the data in the application. You may have admin users, you may have general users, you may actually have like an audit user, and there are different levels of authorization. Now, some other things we should consider are using multi-factor authentication. Absolutely super duper important. If you can use multi-factor, do it. And then we want to configure logging so that we have logging configured. It's logging and we can provide some type of log analysis. And that's part of our access control. Then something else we should consider if we're using this application on mobile devices, BYOD, bring your own device. And here we're talking about BYOD management. So if we're using this application on mobile devices, we may want to actually put an agent on these devices and manage them. So what we're doing is with this agent allows us to manage what applications can be installed on these devices. So here we're talking about other applications. It can prevent jailbreaking of these devices, because some of these activities that users perform on these devices can put the devices at risk, which then puts the apps that are running on it at risk, which goes back to your application. It puts it and its data at risk. So BYOD management might be something you should consider. And then lastly, monitoring. So part of monitoring, we're wanting to monitor the availability of our application, make sure it's there and available. We want to, of course, monitor the security of the application. So at this point, we may request to view an audit of the application. Maybe this vendor has a recent type of SOC audit or some type of pen test against the application. That's something that we would want to do. We'd want to request that audit so we can verify the security of the application. And that is SaaS. And then lastly, across all cloud categories, there's 3 things here I want to talk about real quick. Number 1, know where your data resides. And we've talked about this before, and it is very important. Number 2, review your contracts and SLAs so that you know what you should be getting and you can verify that you are. And then lastly, number 3, this was across all 3 of the categories, and I want to mention it one more time, access control. No matter what cloud service you're using, access control should be a part of that, because this is how we control who can access what. This is our first line of defense. We want to make sure that this is strong and we have it implemented properly, no matter what cloud category, service, solution, etc. we are using. Need to have that access control. Well, that wraps up our security considerations for different cloud categories. I hope it's been informative for you, and I'd like to thank you for viewing. When it comes to the cloud and our data in the cloud, well, there is a life cycle for our data. So there's different steps along the way throughout its life. And we need to understand what those steps are, those phases of our data life cycle, because we need to understand what happens at each point or phase of that life cycle. And we also need to understand who's responsible for making sure that things happen at those different phases. That way we can ensure that our data is taken care of throughout its entire life cycle. So let's jump in and take a look at the cloud data life cycle. All right, so here we are with our cloud data life cycle, and we know that there are 6 different phases because, well, there's 6 blocks down here. So let's start off and take a look at this life cycle. Now we're starting with create. So the idea here is, well, we have to create data for it to exist and be in the life cycle, right? Of course, so we create our data. Then once we create it, well, we need a place to put it. So we need to actually store our data so that it can be used at some point, right? So once you create something, you have to put it somewhere. And after we've stored it, well, then at that point, we can begin to use our data. And that is why we created it in the first place, so that we could use it. And part of using it oftentimes is actually sharing our data. So we share it with other organizations or other people in our organization so that they can use our data as well. Now, once we're finished using our data, oftentimes we need to keep it around for a little while, and so we're going to need to archive that data at some point. Now, here's the thing. When we archive it, we're putting it somewhere for long-term storage until it's time to destroy the data, and that is the final step in the cloud data life cycle, and that is destroy. And we have talked about proper ways to destroy data in the cloud in the past, and we're going to talk about it briefly again. So these are the 6 phases of the cloud data life cycle. Now let's take a minute and discuss each one of these phases a little more in depth. And starting off with create. So yes, we create data, right? And generally, the person who creates the data is oftentimes the owner of the data as well. Now, not always, but most of the time. Now, here's the thing. What responsibilities do you think this data owner has? Well, one of them is to assign a classification for the data and make sure that that data is labeled with that classification. So we might have confidential or internal only or public or private, whatever it is, whatever that classification level is. Well, the owner needs to assign that to the data so that we can know as users of the data how to properly handle it. Because, of course, we're going to have a data handling policy, and that data handling policy is going to include classifications and how to handle data of each classification. Now, something else that the owners do other than assigning a classification, well, they're going to decide who should have access to that data, who can use that data, and they're going to assign permissions to that data, or at least have the data custodians. Those are the people who manage data on a day-to-day basis, usually IT admins, right? Going to have the custodians assign the proper permissions to that data within the systems. So there we go. Once the data is created by the owner, they go ahead and assign a classification to it, and they're also going to decide who should have access to it and make sure that those permissions are set. So, okay, so now we've created our data. We've got it ready to go. It's classified. It's got permissions set. Now we need to decide where are we going to, that's right, store our data. So the question is, are we storing it on premise in our office? Maybe we have a couple of file servers or something here on premise, or maybe we're going to store it out in our cloud service provider's environment. So it's out there in the cloud. Well, here's the thing. If we're going to store it in the cloud, we need to know where it is physically located. And we've talked about this before, and it comes down to one word, jurisdiction. Because where our data resides, whatever country that is, it falls under those local laws. So jurisdiction is very important. That's why we need to understand where our data physically resides if it's in a cloud provider's environment. So we're either going to store it on premise or in the cloud. And again, in the cloud, we need to know where it's physically located. Okay, what else do we need to consider when storing it? Well, how about data encryption? Is this data sensitive? Does it need to be encrypted? Well, if so, then we need to ensure that we are properly managing those encryption keys, because if we lose our encryption keys, well, guess what? We lose access to our encrypted data, and that's going to be a bad day, and nobody likes bad days. All right, so we've created our data, we've got it stored. What are we going to do now? Well, now it's time to use it. Let's break out that data. Let's stretch its legs. Let's use it. Let's process it. Let's analyze it. Let's do whatever we do with our data. But we need to ensure that we have proper IAM. And remember, IAM is Identity and Access Management. And that Identity and Access Management is going to ensure that our authentication and authorization is in place so we can control who's accessing the data. And not only who's accessing the data, right? So that they can access it. So like this fellow over here, he can go ahead and pull up that data and analyze it. But we need to know what this user is doing, right? So we need to have the events logged. And that is part of IAM. It's Identity and Access Management. It's managing the access. It's logging who's accessing it. And that way we have auditability, which is so very important. We need to know who's accessing things so that if we need to audit something or investigate something, well, guess what? We can. We're also going to be performing at some point integrity checks to validate the integrity of the data to make sure that it hasn't been corrupted in some form or fashion. Because if our data is not wholesome, meaning it's been corrupted or is no longer accurate, well, then it's lost its integrity, and we need to figure out why that happened, and we need to restore from backups to where that data was still accurate. So that is using our data. Now, another part of using the data is sharing the data. Oftentimes we share it with other folks in the organization by allowing them to have access to it, setting permissions, or folks outside of our organization. So here's the thing. When it comes down to sharing, we really need to know, do we have a secure way to share our data? Because we need one. If we're sending our data, maybe via email or some type of file upload, no matter what it is, we need to make sure that we can securely share it using some type of encryption. So we're encrypting our data in transit. We've talked about data being used, and one of the ways it's used is in transit. And that's what we're doing when we're sharing our data. And we need to make sure that we are encrypting it, of course. And here's another question. If I send my data off network to a user over here, and this user is in another organization or another environment and not on my network, how can I authenticate and make sure that only this user can access that data? I might have sent it to them, but what if they put that file on their local file server, right over here on the server, and somebody else in their office goes to try to access that file? Well, how can I make sure that I can authenticate the user accessing that data? Well, that's a really good question, and it's something we need to consider when sharing data. And we're going to talk about in upcoming lessons how we can do that. Don't worry about that. But you need to understand that that's something we need to take into consideration. We need to think about it. And then lastly, we need some type of policy around data handling. And we had a data handling policy that we talked about a couple slides ago that dealt with the classification of data. Well, we also need to understand how we can properly share data. For example, we might need to share data via an encrypted email. And we might need to use some type of additional authentication with it, whatever is outlined in that policy. But the thing is, we need to have a policy in place so folks know what is expected of them and how we should properly share it so that we're following security best practice. All right, we've used it, we've shared it, and guess what? Well, it's no longer needed. However, we can't quite get rid of it yet. So what's next? That's right, we're going to archive our data. So the question is, well, how long should I archive my data for? And the answer is, well, it depends. It depends. Is that data used in some type of regulated environment or regulated industry? Well, if it is, then you're probably going to have to keep it for X number of years. I know when it comes to HIPAA, some of the records have to be kept for like 6 years, and when it comes to financial records, some have to be kept for 7 years, and it just depends. It depends on if you're in a regulated industry or not. It really comes out of what type of data is it. So we need to understand that. And guess what? That's right. We're going to have some type of policy around this that defines exactly what type of data should be retained for what period. And then the policy is also going to have to state, well, how and where are we going to store that data? Now, how are we going to store it? Well, we're going to write it to the storage, right? Well, yes, but are we going to encrypt our data for archival? Well, if we are, then we need to have some information about that. We need to know what are our plans for the long-term storage of encrypted data. We also need to decide, of course, where we're going to store it. Is it going to be in the cloud? Is it going to be on premise? Where is it going to be stored? So we will have a policy around data archival. Now, once it's reached the end of its archival period, it's time to finally go ahead and destroy that data. We're going to take this here whopper knocker and we're going to destroy the data. Well, we're probably not going to use a whopper knocker exactly, but we're going to properly destroy it. And guess what we're going to need for that? You guessed it. We're going to need another policy. We're going to need a data destruction policy that says this is how we destroy data. If it's on-premise data, and it's maybe on our own hard drives or something, we're going to destroy it this way. Or if it's in the cloud, well, guess what? We're going to destroy it this way. And we're going to have a policy around that. And the data owner, we're going to go back to the data owner. Remember, the data owner usually creates the data, so they created it. It's at its inception. But guess what? The data owner is responsible for making sure that the data is properly destroyed. Now, they're probably not going to destroy it themselves, right? The data custodian is going to destroy it, but the data owner has to make sure that it's done. And then we need to document the data destruction so we know it was properly destroyed, and we have it documented. We have log history. We can go back and verify this. And remember, earlier in the course, we talked about something called cryptographic erasure, which also went by the term crypto shredding. And this was the best way to destroy data in the cloud. That's right. So if you do have data in the cloud, cryptographic erasure is going to be your go-to when it comes to destroying that data. And those are the 6 phases of the cloud data lifecycle. Now let's do a quick review. First of all, what did we do? That's right, we created the data. Then we were able to store the data. We had to store it somewhere. After we stored it, we could go ahead and we can, that's right, use it. And sometimes when we're using data, we like other people to be able to use it as well. So guess what? We share it out. And once that data has come to the end of its useful life cycle, that's right, we're going to go ahead and archive that data. Once we have reached the end of the archival period, we can go ahead and destroy the data. And guess what? It all starts over again. That's right. Somebody's going to create new data. And so here we have the cloud data lifecycle 6 phases. There it is. I hope this has been informative for you, and I'd like to thank you for viewing. In the last video, we talked about the cloud data lifecycle. So we understood data from inception to destruction and everything in between. Well, one of those steps was to use the data. And there are actually 3 different ways that we use data. We refer to them as data functions. So let's jump in and take a look at these 3 data functions. So what are these 3 key data functions that I talked about? Well, the first one is access. We need to access the data before we can do anything with it. Okay, now that we've accessed the data and we have it on our machines or in our hands, we have it, we can do something with it. What are we going to do with it? Well, a lot of times we actually use it to process. We process the data. So meaning we have maybe a system or something like our little sprockets over here, and we have an input. So we input our data, and then of course we're going to get an output. So we're processing this data. We're getting value out of the data. And once we're finished with that, well, guess what? We need to store that data somewhere. And we might store output, and we could store the original data as well, but we're going to store it somewhere. We can't have it sitting in our hands or on our desktop open forever, right? We got to put it somewhere. So those are the 3 key data functions: access, process, and store. So how can we control and manage these various functions? That is a very good question. And one of the key pieces to this is IAM. That's our Identity and Access Management. And that's because IAM does quite a few different things for us. Not only does it control who can access something, it can also control what they can do with it. And specifically, we're talking about read, write, and execute when it comes to file permissions. So who can read data, who can write to the data, meaning make changes to it. And if it is data that is a program or application or script, well, who can execute it? And then IAM also, of course, provides us with logging capabilities so we can know who is doing what with our data, and we have auditability. So IAM is very important. So let's take a look at controlling access to data. Now, of course, IAM is going to play a very large role here, right? We're controlling who can access what, and that's what IAM does. And it uses things like security groups to determine who can access what. So these security groups, we might call a group accounting. And we might have a security group in our system called HR, one for R&D, one for executives. We'll say execs. There we go. So we create these different groups here, and then we go assign various users to these different groups. So we got some HR folks, we got some R&D folks over here, and you get the idea. But we're assigning these users to these groups, and then when it comes to the actual files that we have, we can assign those roles through IAM to make sure that only those accounting folks can access this file. And that's kind of how it works. Now, we also need to think about, when it comes to controlling data access, data encryption. And that's because if I encrypt data, only those with the key can unencrypt that data. So I can control who can access it by encrypting it. So if I encrypt some data, this is me over here, and I've got a friend over here at another organization, and we work together and we're collaborating on a project. I'm going to go ahead and send this blue guy over here. I'm going to send him an email, and in this email I'm going to put an encrypted file. So it goes across the internet, goes over here, and Mr. Blue is able to open the email and actually read that file because he has the key to open that file because it was encrypted. Now here's the thing, here's really what I'm getting at with this. Well, this file goes across the internet. And out on the internet, yes, it is possible that someone could intercept or read or carry out what we call a man-in-the-middle attack to read the contents of my email. Well, here's the thing. If I encrypt using an encryption key that file within the email, they're not going to be able to read that file. So I'm controlling who can, here we go, who can access what. So that's where encryption comes into play in controlling access. And there is one more thing I want to talk about, and this one is called Digital Rights Management, DRM. Now, digital rights management is really a type of system that you can use, and you can apply permissions directly into a file. And these permissions reside outside of the operating system they reside on. So in this instance down here where I sent Mr. Blue a file, if this file was on my local file server here on my network, well, it's going to have the security groups associated with who can access that file. But once I send it outside my organization, this organization over here knows nothing about my security groups, right? So the local file permissions don't apply. But using DRM, I can apply permissions directly into there, so they're embedded in this file. So when Mr. Blue opens it, he can do certain things only. Now, when it comes to DRM, there's some pretty neat aspects to this because I can actually not only control who can read that file when it leaves my organization, I can control what they do with it. Meaning, maybe I disable copy and paste, so they're not able to copy what's in the file. Ooh, that's pretty neat. I can also disable screenshots. So when a user tries to get a screen grab or a screenshot of that document open on their computer, well, it doesn't work. I can also prevent things like printing of that file. Well, that's pretty cool, isn't it? Absolutely. I can do lots of different things when it comes to controlling who can do with what with this file using DRM. And this is key. You want to use DRM when that file is leaving your organization, when that data leaves your organization, because when it's in your organization, you have your own local security groups and settings that are going to control access to and protect the file. But once it leaves your organization, well, at that point, it's out of your hands, right? If you put that out there on the internet, post it somewhere, well, anybody could access it. Well, if you used a DRM system and you posted it out there, only those who you authorize to access it and use it and do these various activities with it would be able to do so. So that is pretty darn neat technology. Now that we've talked about controlling data access, let's talk about controlling data processing. So here we go. We're ready to process. We're ready to do some experiments over here with this data. And here we go. IAM is in the mix again. And that's because IAM is controlling, here we go again, who can access what, also who can do what. Because when we talked about those file permissions, we had read, write, and execute. Who can read the data, who can write or make changes to the data, who can execute the data if it's a program or application or script. So IAM is going to help us to control these various activities. Here's something else when it comes to data processing. What about data encryption? If our data is encrypted, can I process that data? Well, not in an encrypted format. So that means if we have an encrypted file, we're going to have to decrypt the file. So we're going to decrypt it, then it can be processed. And then we're probably going to want to go ahead and encrypt the output of that processing that occurs. So here we go. We're using IAM again to control who can process data, and we got to keep in consideration our encryption when it comes to processing, because we're not going to be able to process encrypted data. All right, next up, controlling data storage. So why is this important? Well, we need to be able to control where users can put data. We don't want them putting it anywhere. So really this comes down to two things. Number one, policies. We've got to have policies about data handling. So I'm going to put over here data handling. Definitely need to have a data handling policy so that we say this data cannot leave the organization if it's X classification. So that means you can't store it in another area off the network. It has to be kept within our organization. And we're also going to have policies around data handling that deal with a very sensitive subject matter, USB storage. And what I mean by sensitive is because a lot of times people will put information or data on those little USB sticks or thumb drives because it's very convenient. I can throw that in my pocket if I need to and go somewhere else and work from home with it or whatever it might be. But those things can also be lost, and oftentimes they are. And then what do we have? Well, possible data compromise, possible incident that has occurred. So oftentimes organizations will have in their data handling policies that you cannot store data on external storage devices, and that does include USB. So how do we go about dealing with this? Well, when you have a policy, it is a written policy, but you could also define a system policy, and this is a technical control, meaning it's technical on the system, so the system itself is going to prevent something from happening. And so what we do is we set up a rule in the system that says do not allow USB mass storage devices to be plugged into a computer. So that way when someone tries to plug it in, it's just not going to recognize it. And that will prevent the transfer of data to a USB storage devices. So not only do we have a written policy, we may also have a system technical policy as well. So policies is the first line of defense, and second is our digital rights management that we just talked about, which is so cool because within the DRM, we apply rules directly into the file. They're embedded in that data. So when it leaves our organization, those rules go with it. And one of those rules could be copy, so that you can't copy that data somewhere else. You can't copy it and paste it. You can't cut and paste it. You can't move it, basically. It's on your system, and that's where it will reside as long as you can access it. So that DRM is pretty darn handy. And that is controlling data storage. And those were the three functions. We had access as our first function, so we can access the data, because if we can't access it, we really can't do anything with it. And once we had access to it, we were going to process that data. That's where we use that data as an input into a system. And then on the other side, we had our output, and that was making data useful. We got value out of our data. And then lastly, we're going to store that data, because once we access it and we process it, we're not using it anymore. We need to store it again, but we need to control where that data can be stored. All right, there we go. That's access, process, and store, our three key data functions. I hope it's been informative for you, and I'd like to thank you for viewing. I'm sure you've heard the saying that it's not good to have all your eggs in one basket. Well, the same is true for data. You don't want to put all your data in one location, because what happens if that location is no longer available? Well, I'll tell you what, if it's no longer available, well, your data is no longer available either. So that means we should think about where we're going to put our data, and it shouldn't be all in one location. So that brings up the idea of data dispersion, and that's what we're going to talk about right now. So when it comes to data in the cloud, and just data in general, we need to know data location. That's important. We've talked about this before. And the thing is, in the cloud, well, data moves between locations. You might have some data here in the US, and it may be replicated over here to the EU, maybe down into Africa. There's no telling where it's going to be replicated. But the thing is, oftentimes it's replicated or moved between locations, and that can be a very good thing. But we need to keep in mind, we need to know where our data is located. Now, cloud services are designed to be redundant, and because of this, oftentimes this data replication between sites happens, so that if one site goes down, well, the other sites can still be accessed and your data can be accessed, and that is a good thing. That's redundancy, right? We like redundancy because it ensures that we can still access our data if something goes wrong with one of our sites. Now, when it comes to data backups, well, these are generally sent offsite as well. So if we have our data here, we might actually back it up to a location up here in Canada. And the thing is, that's good because that is data dispersion. We're moving a copy of our data off to another location. so that if something happens to our primary location down here, well, that's okay. Our data is still accessible somewhere else. And critical data should be stored in multiple locations for redundancy. So especially when it comes to critical data. So we'll put that over here, critical. I'm going to put a star next to it because it's pretty important that we have redundancy for critical data, and it's located in multiple places for the sake of survivability in the event that one of those disasters comes knocking on our door. And that's not a good thing. However, when it comes to data dispersion and having it in many places, we need to know where our data is. And we've talked about this before. It's very important. And why was it so important? It came down to one word. What was that word? If I could only remember. Aha! That's right, it was jurisdiction. The jurisdiction of our data, because remember, wherever our data resides in that country, it falls under that country's laws and regulations, which is the jurisdiction. So we need to know where it's at, especially if we're working in regulated industries. Next up is something called storage slicing, and of course this is part of data dispersion. Now, storage slicing, this is really pretty interesting, and it's a technology that separates data into chunks. So we have our original data here, and it's broken out into little chunks. So there we go. There's our little chunks of data. And they are dispersed geographically. They're sent to different areas, different data centers. And that way, they're not all in one location. So when you go to access this data, so I'm over here, I'm going to click on opening that file. Well, the management system for it's going to go out and it's going to grab all those copies and put them together and provide them to you as one single unit or piece of data. And that is pretty neat because that's an automated form of data dispersion. But what happens if maybe this data center is offline? Then you're missing piece of the data. Well, that's not good. Well, don't worry about it because storage slicing thought about that well ahead of time. And they use an additional piece of data called erasure coding. And it's a form of error correction so that this data can be rebuilt. So if one of these is offline, there's enough other information that this data can be rebuilt as a whole. And it's much like the parity that we use in RAID. And RAID is a group of hard drives. So if we had hard drives here and we put them into a group like this, they would act as one unit, a logical drive. And it would store information on each of them. But there was also something called parity that was stored that went along with it, so that if one drive was lost, the parity could be used, like the erasure coding is used, to rebuild the missing data. So that is storage slicing. It allows you to have automated data dispersion, which is pretty cool, and allows for error correction in case one site isn't available when you want to read your data. So that's pretty darn neat. Now let's talk about data dispersion when it comes to various types of cloud services, such as infrastructure as a service, or IaaS. Now, when you set up your account, when you're building your infrastructure as a service, you can elect to have your data replicated to various other data centers. But by default, this generally doesn't happen. So when you spin up a new virtual machine over here in your environment, you will need to tell it that you want to replicate your data or your VMs to another data center, and you're going to select kind of usually like a region where you want it to be replicated to, and then you're going to have some additional charges that are incurred with this because you've got bandwidth of sending that data over there, and then you've got resources that you're using at the other side to have your replicas sitting there. So you're using storage at this point because they're not up and running necessarily, so you're not using compute, but you are using storage that you'll need to pay for. So when you're setting up your IaaS or your infrastructure as a service environment, keep this in mind. Data dispersion is not automatic in all cloud providers. So when you're setting up your environment, you may need to set up data replication. Now let's talk about platform as a service and software as a service. These are completely different than infrastructure as a service. So here we're relying on the vendor. They're either providing us some type of platform or an already built software. And most of the cloud providers out there, if not all, are going to provide some type of backup for your platform setup and your software. So generally you won't have to worry about that. And they're going to be providing some type of data replication of the platform and of the software, because that provides redundancy for them, which helps provide you better services. However, you want to double check this, because not all cloud vendors are the same, and you actually might have to pay a little extra for this replicated service or a backup of your data service. Most often it's taken care of, but just double check to be safe, because it's always better to be safe than sorry. And that has been data dispersion and the importance of having our data in more than one location. I hope this has been informative for you, and I'd like to thank you for viewing. Earlier, we discussed the cloud data lifecycle, and after we created our data, well, the next phase was to store the data. Now, when it comes to cloud, well, what are my options for storing data? Because I know there's various cloud services. I got infrastructure as a service, platform as a service, and software as a service, right? And I'm guessing those options are going to be different in each of those because they work differently. Well, if that's what you're thinking, you're absolutely right. And now we're going to jump in and talk about some of our cloud storage options. So, starting off with infrastructure as a service, we're talking about cloud storage types. And when it comes to IaaS, what types are available? Well, we really have three of them. The first one is volume storage. And this is what you're going to attach to a virtual machine. So this might be your Windows C drive or D drive, or it might be your Linux. We've got a Linux over here. Maybe it's your dev/SDA, right? Whatever it is, it's going to be your drives that you're dealing with your virtual machines. That is a volume. And that's volume storage. All right, that's one of them. So let's put a line down here. What other types of storage can we use? Well, we can use object storage, and this is a little different. This is where we store much of our files, right? This basically, think of this as a pool of storage where we can store just about anything, like a big file share that's out there. Now, when it comes to AWS, they have this, of course, and it's called S3. And when it comes to Azure, they have this as well, and theirs is called Blob, Azure Blob. And these are a couple examples of object storage, and really it's just a storage pool where you can store just about anything. And actually, this is where your VM images are stored by the CSP or cloud service provider. They actually store your VM images within object storage. And then lastly, we have something called ephemeral storage. And this is temporary storage that's used by your VMs while they're up and running. But as soon as you turn those VMs off, you power them down, well, that storage is no longer used. So it's relinquished and other instances can use it. Now, this is something that we really don't have control over. This just happens in the background. So when it comes to selecting storage types, you're going to be selecting a volume storage or an object storage. Because again, ephemeral is something that just happens in the background as part of the IaaS services. All right, next up, platform as a service or PaaS. Now, when it comes to storage types with our platform as a service, really there's two main types. The first one is structured, and this is a structured form of storing data. Now, this is going to be something like SQL, structured query language, SQL, or MySQL. There's various types of SQL. There's MS SQL for Microsoft SQL, MySQL. There's various types, but basically it is structured. Here we have in a SQL database, we're going to have tables, and in the table we have rows and we have columns, and this makes up our structure. Well, if they're structured, there's probably unstructured, and you're absolutely right. So unstructured is the next type of data storage in PaaS, and unstructured is different because it doesn't use tables and columns and rows and things like that like SQL does. And it's used to store lots of different types of files. An example of this is NoSQL, because if you have SQL up here, down here we have NoSQL. So it's unstructured. a different type of data storage. So those are our two storage options for platform as a service. And when it comes to software as a service, what do you think about that? Think about it for just a minute here. What do you think our storage options with software as a service are? Well, the answer is whatever they give to us. That's right, because if we are a customer of software as a service, well, we don't have to worry about it. We don't have to worry about selecting storage types and things. That's all managed by the cloud service provider. We just use the software. So when it comes to SaaS, whatever they provide us, that'll work. So moving on, some additional storage types. Well, the first one is called raw storage. Now, this isn't something you really see in public clouds. You could see it in a private cloud environment. And what it is, this is also known as raw device mapping. And it's known as raw device mapping, or RDM, for a reason. That's because here's how this works. So basically, we have over here something we're going to call it a storage area network, or a SAN. And I'm going to have my hypervisor machine over here, and I'm going to connect to the SAN in some form or fashion. And then I'm going to use its storage, right? That's how it works. But what I want to do is, instead of getting a representation of some data over here to my hypervisor, I'm actually going to connect to a specific piece of storage on this SAN. And I'm doing this for a specific reason. If I can connect directly into the hardware on this SAN, then I'm able to use some of the features of the SAN. And generally what we're talking about when using features, one of them is called storage snapshots. And that's where the SAN here is going to take a snapshot of an area of storage. And it's going to keep that snapshot so it knows exactly what it looks like. And then down the line, maybe 2 hours later, something happens to that data and we need to revert quickly. Well, we can revert quickly to a previous snapshot. Now, will you lose the data that had changed in the meantime? Well, the answer is yes, but it's a quick way to jump back or fail back in the event of an emergency or disaster. And that is raw device mapping. You're mapping raw storage locations on the SAN, because generally the way the SAN works is you carve it into chunks like these here. Let me use a different color, might be a little better. Like these here, these chunks, and we refer to those as a LUN. But the SAN is acting as a go-between. So the hypervisor sees it as storage here and doesn't see all the underlying aspects that happen on the SAN. But when you use raw device mapping, you get direct access into the SAN and its capabilities. So there you go. If you wanted to use something like storage snapshots, you could use raw storage. But again, this isn't something we see in a public clouds because we don't have access to the SANs and the SAN snapshots and things. This would be something we do in a private cloud. So what other types do we have? Well, how about long-term storage? We talked about our cloud data lifecycle, and one of those phases was data archival. So when we go to archive our data in the cloud, when we're dealing with storage, we have production storage that we've talked about. And let's stick with infrastructure as a service. We had our volume and object storage within production that we were using. This I'll put over here, IaaS, there we go. And we were using volume and object storage. Well, that's for production, but what about when I want to archive data? Is there a better way to do that? And the answer is yes. We're going to be looking for long-term storage solutions, and that's key here, because within your cloud providers, they offer long-term storage solutions. Now, in AWS, they offer something called Glacier, and in Azure, they offer something called Storage Archive. Now, why would we want to put our data that we're archiving into long-term storage options such as Glacier and Archive? Well, the answer is $signs. That's right. Because generally speaking, these solutions, these long-term storage solutions, are on low-speed drives of mass storage, right? So you can put a ton of data in there, but it's not very fast. So you're not wanting to use it in production. But that means that you can save quite a bit of money, because these long-term storage options can be much cheaper than your production storage. And I'm just going to throw an example out there. This isn't real money, but at one point it was pretty close. You might pay 5 cents per gigabyte of production storage. But when it comes to long-term storage over here, you might pay 0.005. So half a cent per gigabyte. So it could be 10 times cheaper. Now, I don't know if it is at this point in time, but that's to give you a reference. It can be dramatically cheaper to use long-term storage. But here's something you need to understand about this. When it comes to long-term storage, it will take you several hours to gain access to your data, most likely. It may take up to 24 hours to gain access to your data. It depends on your provider and how many requests they have to pull data from long-term storage, because it's very slow and it's a process. You have to request access to it. They have to get it for you, and that's why it is so cheap. So just remember, if you're using archival as some type of long-term storage, if you need to pull that out of there, it may take a while to do so. And lastly, we have Content Delivery Network, or CDN. And this is where you have files stored in various geographical regions so they can be more quickly accessed by their users. Now, let's look at an example of this. Let's say you start up a streaming media content and you're based in the US. Well, then you might have a data center on the West Coast over here, and you've got your data there, and you stream it to users all over the US. There we go. We're streaming just like that. All right, great. Now our users are able to access data. Now I want to expand. I want to expand up to Canada. Well, can I stream data up to Canada from here in a timely manner? Well, probably so. All right, so I'm good there. I'm going to start going to South America. So now I want to stream down to South America down here, and I find that the further I get from my data center, the more latency I'm experiencing. Well, not me, but my users are experiencing, meaning they're having slow streaming times and lots of buffering. Well, that's not going to work very well, is it? Not at all. So what I need to do is stand up a new data center down here to service South America. And then as I go global, I'm going to spin up new data centers around the world so that I can service customers better that way. And this idea, because what I'm going to do is replicate my data to all these different places so that when those clients try to access my streaming data, they're going to access the closest data center to get the best experience. And that's what CDNs are all about. They're about pushing your content out to various locations within a content network so that your users can have a better experience because they're accessing a local data center instead of trying to traverse large geographical areas and experiencing latency and slowness, which nobody wants. And that's where CDNs come into play. So there we go. Various types of cloud storage for infrastructure service, platform as a service. We talked about our raw device mapping when we're taking advantage of features like storage snapshots of a SAN. We talked about our long-term storage with our AWS Glacier and Azure Storage Archive. So we're using this for our data archives. And then, of course, content delivery networks. I hope it's been informative for you. I'd like to thank you for viewing. All right, we just finished talking about various cloud storage types. And when it comes to cloud storage and the storage of our data, well, oftentimes it comes under attack by various threats that are out there. So we're going to take some time and look at some of these more common threats and some ways that we can address those threats and try to prevent them from causing harm to our data. So the first one we're looking at, the first threat that is, unauthorized access and use. All right, now here's how we're going to do this. We're going to start with a cause. I'm going to C for cause, and we're going to put S for solution. So the cause of unauthorized access to our data is basically lack of access controls. So we have a lack of really IAM in our access control. So that means that somewhere along the lines we have a weakness with our access control. So obviously we need to fix that. Now, there are some other things that could come into play because in here, other than simply weak access controls, there could be account hijacking that has taken place. That does happen. Yes, so we can't blame everything on just weak access controls. Or there could be some phishing that goes on to get credentials. So what are some ways or solutions that we can help prevent this from happening? Well, number one, we need to verify that our IAM is functioning properly. And then we could use multi-factor authentication, because if there is an account hijack or phishing for credentials, MFA will prevent that from happening, because of course with our multi-factor you can't just have a username and password anymore, right? We have to have one more type of factor. So it could be a rotating pin, or it could be biometrics or something like that. But this will help take care of our account hijacking and phishing. So if we verify our IAM and we use MFA, well, guess what? That's going to really help solve our unauthorized access and use threat. So let's move on to the next one. It is liability caused by regulatory noncompliance. So here we're going to have a cause and then a solution. Now, our cause is obviously we're not taking regulatory compliance very seriously as an organization. So we have a lack of security governance and internal auditing. So there we go. That's our cause. So what would a solution be? Well, how about we have some auditing going on? So we're going to perform self-audits. Absolutely. That is definitely a good thing to do as part of any security program. So we're going to perform self-audits, and we actually may introduce some third-party audits as well. And that will call us to the carpet where we are lacking in our security governance, and it'll help us identify them and solve that. Next up, denial of service and distributed denial of service attacks. So here we're talking denial of service. Well, what would the cause be, and what could some solutions be to this? Now, a cause could be a single point of failure. Absolutely. So we have a single point of failure. That definitely could be, because if you're attacking that single point, the attackers, that is, if they're attacking that single point, then they could cause an outage. It could also be a lack of edge security. So by edge security, really what we're talking about is our firewalls and intrusion prevention systems, things at the edge of the network. So that could be a cause. What are some solutions, do you think? Well, a solution could be to introduce rate limiting or connection limiting, because that's going to limit the number of connections or how much bandwidth a single connection can use. So if we're being hammered by a denial of service attack or distributed denial of service attack, well, each of those can be limited to a single connection or two connections and a little bit of bandwidth. So it's going to help prevent a denial of service attack. Well, something else we could do would be to subscribe to a denial of service prevention service. And that would be something like Cloudflare that's out there. It's a really popular one. And the way that works is you send your traffic through your provider, your denial of service prevention provider of that service, and then they forward it on to you. So they filter out any denial of services so that they don't actually hit you directly. So there you go. That's denial of service. Well, what about like corruption, like data corruption? What could cause data corruption, and how could we solve that problem? Well, data corruption could be because loss of power. So we have servers or storage devices that are crashing, which is not good at all. And the hard drives stopping instantly like that without being able to offload data or do whatever they need to. Or it could be simply just bad hardware. Both of those could cause corruption, right? So how can we solve this? Well, number one, we need to have regular backups so that we can recover from data corruption. Okay, that's pretty important, but that's not really going to solve the problems. We need to update firmware of our devices, and even hard drives have firmware on them. That's going to help, because if there's bugs in the firmware causing hardware problems, that's going to fix that. And we also need to set up monitoring. And that monitoring is going to alert us if there are errors being thrown by hardware, so that we can identify those errors through monitoring and we can prevent outages by scheduling downtime and updating firmware or fixing the hardware, whatever those errors are throwing in our monitoring, so we can prevent that. So instead of responding after the fact, we can actually be preventing those problems from happening. There we go. Great. Well, what about a data breach? That is definitely a threat. So let's talk about our cause and our solutions. Now, a cause to a data breach could be insufficient security. So here we're talking about lack of policies, lack of procedures, lack of controls, general insufficient security. Well, how are we going to address that? Well, the first thing we could do is perform a security assessment, because this is going to help us find weaknesses and fix them. There we go. That would be awesome, because this is a good starting point. It's going to point out our weaknesses. Then we can beef up our security so that it's no longer insufficient. Something else that we could use is a data loss prevention system that we've talked about before. And this would help identify sensitive data and protect it so that it can't be exported. So let's say somebody does get into our environment. Well, they're not going to be able to export or get that data out of our environment. So it's going to help keep it in the environment. And that is just an additional layer of security that we can help protect our data from a data breach. Next up, theft or loss of media. Now, let's talk about this. This is a good one. Cause and solution. Now, the cause is going to be human error, right? We know that. So we're going to say human error. All right, there we go. And what allows this to happen, though, if really, when we're talking about theft or loss of media, when is it a big problem? Well, it's when data is compromised, when this happens. So that means usually we're losing USB devices or laptops, and the data on them is being compromised. So somebody could log into them and access the data. So how are we going to solve this? Well, number one, we need a policy around data handling, of course, and taking data off-site and equipment off-site. So we got a policy for that. What else can we do? Well, how about we force the encryption of all data on USB and laptops. So basically, USB devices will be encrypted and laptop hard drives will be encrypted. That way, if they are lost, the data cannot be recovered from them by someone who doesn't have authorization to do so. So that's how we could prevent unauthorized access to data because of theft or loss of media. There we go. Next up, malware attacks, specifically ransomware, right? That is pretty darn bad stuff. So we have our cause, we have our solution. The cause of malware attacks is usually human error. Of course, we go back to human error. That's most likely the cause of this, because somebody opened something they shouldn't have, an attachment, or they clicked on something they shouldn't have. So how are we going to solve this? Well, number one is security training. So security training for everybody. Everybody gets security training. You get security training. You get security training. And once we have security training, we need to keep our endpoint security. That's our antivirus, anti-malware, endpoint detection response, our endpoint security solutions up to date. That is very important, because if we don't keep it up to date, it's not going to be able to protect our endpoints. And then lastly, we're going to want to make sure that our backups, our data backups, are kept off network. Because if ransomware attacks, we know that the way it works is it infects a single device, and then it spreads looking for anything it could access and encrypt. That's why we want to make sure our backups are kept off network. If they're off network, they can't be encrypted, and we can recover. There we go. That is the malware attacks. And on to our final threat to storage: improper data erasure or improper device sanitation. So we have our cause and solution. All right, what's our cause to this? Well, data not being properly sanitized. So improper sanitization. So what's our solution? Well, we should have a policy, a data destruction policy that tells us exactly how we should be destroying our data and sanitizing our hardware. Now, we know that in a cloud environment that crypto shredding or cryptographic erasure is our best bet, and that is in the cloud. And then on premise, we could actually use physical destruction or degaussing, or of course crypto shredding as well. But the idea here is we need to have a policy in place that dictates how we should be properly erasing our data and sanitizing our devices. That way we can follow that policy and we can make sure that improper sanitization is a thing of the past. And that is several different threats to storage, some of the causes of them, and solutions, ways that we can address them so that they are not a problem and we reduce the likelihood of that threat causing harm in our environment. I hope this has been informative for you, and I'd like to thank you for viewing. When it comes to our data, of course, one of the things we need to do is protect that data. And one way we can protect our data is to use encryption. We can protect who has access to it through encryption, which we can then use that to guarantee its confidentiality, and we can help ensure its integrity. However, when it comes to the cloud, well, things are a little bit different, as you can imagine. So let's jump in and talk about encryption in the cloud. So starting off, data. Data at rest, data in use, data in transit. Those are the three states of data. So of course we have at rest, and that's where the data is sitting on a hard drive somewhere. It's not being used, it's just sitting there idle. Of course, we also have in use, and that's where we are using our data. We're using it as generally some type of input into some type of system so it can be processed, and then we get an output out of it. And really, this is where we get the value from our data when we use it. And then lastly, we have in transit, because we oftentimes need to share our data, right? We might email it to someone. We might upload it to some type of file server so it can be shared. Or it might be data that's going off network for some type of backup purpose. So either way, we have data in transit. So here we have at rest, in use, and in transit, and we need to protect it during all three of these phases. And I talked about using encryption. So when we use encryption, we can help protect our data, right? Because we can control who has access to the data. If they don't have the encryption keys, then they can't access that data. They can see an encrypted file or files, but they can't actually gain access into our data and see it. So there we're protecting the confidentiality of our data. And if they can't access it, well, then they can't change it, so we can help protect the integrity of our data. So those are two things we're really looking to protect here, confidentiality and integrity, when using encryption. Now, as I said, encryption helps us protect data, but how do we use encryption? Kind of what's the process involved? Well, the encryption process includes three items. The first item, well, you guessed it, data. If we don't have data, we don't have anything to encrypt. So there we go. We have data. That's our valuable assets. I'm going to put that over here. That is our valuable assets. That is or are data. And that's what we're wanting to protect because they are valuable to us. Well, then we have something called an encryption engine. And this is the device or application that actually performs the encryption process. And again, this could be an application, so it could be software encryption, or it could be a device, so it could be hardware encryption. And then lastly, we have encryption keys. And these are the values that we use and plug into our encryption engine, and then out of which we get our encrypted data, also known as cipher data or ciphertext. So the idea here is we have our data over here. We have our plain text file. We have our encryption engine over here that's going to do the encryption. And then we have our encryption keys, the values we're going to plug into that engine. So when we put all three of these together, out comes our output from the encryption engine, and it is our encrypted data. So this is going to be information that we're not going to be able to read without having the proper encryption keys. And that is the encryption process. Now, I did say when it comes to the cloud, things are a little bit different. Yes, that is very true. We have some additional challenges to deal with. So let's talk about some of the cloud encryption challenges. Now, the first one we're going to talk about is that keys can reside on premise or in the cloud, but they've got to be protected from unauthorized access. So we're talking here, key protection is very important, and that's true even when you're not in the cloud. However, the thing is, if you're going to store your keys in the cloud, well, then they're not on premise. So you have some additional complexity involved in protecting the keys in the clouds. Secondly, in the cloud, well, we have a multi-tenant environment, which means you're sharing the underlying hardware. And it is theoretically possible, especially when it comes to memory, we're going to say our memory down here, our RAM, that when certain data, specifically encryption keys, are stored in RAM during the encryption and decryption process, that if another tenant had access into the same RAM registers, that they could read your encryption keys. Is it possible? Yes. Is it likely? No. So I'm not wanting to scare you here. I'm not trying to say you can read everybody's information when it's in RAM. No, that's not exactly true. However, this is possible, and it's one of those kind of theoretical things that's out there that people like to say, oh, look out for cloud security in the memory. It's a multi-tenant environment. And I just want to say real quick, is it possible? Yes, it's possible. Is it likely? No, it's not very likely that this would happen. The next challenge is performance. And that's because when we're using encryption, it can influence performance. And here's why. If I have a system that I'm processing data with and I store my data in an encrypted format, well, I have to decrypt that data. So now it's plain text, it's readable, before I can use it as input to be processed. And then once it comes out as plain text data still, then I would go ahead and re-encrypt it at this point. Now here's the thing. This process here of decrypting data prior to processing, well, they can cause some latency. And that's where performance comes into question. Now, if you're dealing with highly sensitive real-time information processing, well, then it might be a problem. You might need to address it. But for most everyday uses, it's not going to be an issue. But it's something that needs to be pointed out that encryption can impact performance. Another challenge would be if you're using some type of cloud processing services and your data is encrypted, well, as you guessed it, before it can be processed, like we just talked about, it's got to be decrypted. So if you're storing your data in encrypted format and you're going to have a cloud service process your data, you need to decrypt it prior to that process happening. But here's the thing. You probably want to do this in the cloud. Because if you do this on premise and send unencrypted data across the open internet to your cloud provider, well, that could be a security risk. So you'd want to ensure that you have a VPN or something, an encrypted tunnel that you're sending this data over to protect it in the meantime, if you're not doing that in the cloud already, that same CSP. And then lastly, when you're dealing with cloud services, sometimes cloud services will require you to use a single encryption engine. And if it is a single point encryption engine, meaning there's a single service that you send this to and there's not a redundant service, well, then this single encryption engine that's going to do the encryption process is a single point of failure. So when you're using encryption services in the cloud, you want to ensure there is some type of redundancy built into it, because this isn't something you manage. This is something that your cloud service provider manages, and you need to ensure you have redundancy so you don't have that single point of failure. So there we have it. Data at rest, data in use, data in transit. As our data goes through its life cycle, we need to consider encryption to protect it. And of course, using our data, the encryption engine, the encryption keys to make that happen. And then specifically looking at some of the challenges that we see when using encryption in the cloud. I hope this has been informative for you. I'd like to thank you for viewing. In the last video, we talked about some of the challenges of using encryption in the cloud, as well as some of the ways that we do that. Now, let's focus a little more on the cloud, but we're really going to specifically look at infrastructure as a service and some of the encryption options that we have when using IaaS. So we're starting off with basic storage level encryption. Now this is the encryption that takes place on a storage device. So it might look like this. We have SANs or storage area network devices, and basically they're just full of hard drives, and you can store a whole bunch of data on them. And they offer encryption services on them. And the idea here is that the hardware itself is encrypting all of this data that is on those drives. So if someone was to go and grab one of those drives and pull it out and try to read the information on it, well, you know what they're going to get? A whole lot of nothing. They're going to be able to read zilch because that data has been encrypted, right? So it protects the data while it's at rest on this device. Now that is all great and good while data is at rest. But what about when data is in transit or in use? Well, at that point, this type of encryption doesn't really protect the data. So what options do we have? Well, let's take a look. First one is volume storage encryption. Now, this is the volume that you think about when you think about an operating system. Maybe your Windows, you've got your C drive. And when we take a look at a virtual machine, when we go through the settings, we're building a virtual machine over here. One of the things we're going to do is assign a hard drive, and we're going to give it a size. And then this hard drive here will become a volume within our operating system. And that's where the volume storage encryption comes into play. So we're wanting to encrypt this volume so that it's protected. And when we think about this, this is a virtual machine, and all of the objects created within the virtual machine, like our hard drive, are actually a file that reside on the hypervisor. So this C drive or volume, when it comes down to the hypervisor itself, well, it's simply a file. And if it's encrypted, like a volume storage encryption would do, then if someone was to make a copy of this hard drive file, we'll put HD up here for hard drive, if they make a copy of this file and they go and they attach it to their own VM so that they can try to read that file, you know what they're going to get? You guessed it, a whole lot of nothing. That's right, zilch. And that's great because we've protected that data. Now, I do want you to understand, if you log into, let's say, this VM here, so you go ahead and you log into Windows and you access that C drive, well, it's unencrypted at this point because the operating system is using it and reading it. So if someone was to hack into or breach your device, this type of encryption is not going to protect that data because they gained access into your operating system and can read it. However, it does protect the underlying files that make up those volumes. All right, that's our VM type encryption that we're talking about. But what about other types of files, like when we're using object storage? We talked about our Amazon S3 and our Azure Blob, where they are object storage services. And we can store all kinds of files within these services. And when we're storing these individual files, well, wouldn't it be very useful if we could encrypt it? Well, absolutely. And that's where object storage encryption comes into play. And it really comes in two forms. The first one is file level encryption, and this mainly comes in the play of IRM or DRM. And IRM is information rights management that we've talked about previously, and DRM is digital rights management, and oftentimes these are used interchangeably. They do the same thing. But remember, IRM is where we were able to create rules, access rules, who can access it, files that is, who can access our files, and what they can do with it. We talked about the who can access it and what they can do with it. And those rules we were able to create and attach directly into the file. And that allowed us to protect that file. And we could actually encrypt it at that point. So that is our file level encryption. And it's that because we're actually doing it at the file itself, at the file level. And then we also have a second one, and it's called application level encryption. And this is where we have, let's say, an application here. We're going to call it app for application. And within our application, we have an encryption engine. So what that means is it can actually ingest encrypted files. So if I have an encrypted file here, we can put it into the application, into its encrypted format. And then the encryption engine down here will decrypt it, go ahead and process it, and then it'll hit another encryption engine, or probably the same one really, and output the output from the processing, but in an encrypted format. And this is called application level encryption. And that's where the application performs the encryption and decryption processes within it. So you don't have to decrypt data before you put it into the application. Now that is pretty darn handy. So that's our object storage encryption. We got one more to look at, and this is database encryption. So when we've got those databases out there that we're dealing with and we're wanting to encrypt our data, well, how do we go about doing that? Well, we've got a couple of options. First of all is our file level encryption that we just talked about. You remember we used IRM or DRM to make that happen, and that's because these databases, well, guess what they are in the end? That's right. They're just a file that resides on an operating system somewhere. And that file is put into a database system, at which point it can be read and used as a database. Our second option is our application level encryption that we just talked about on the last slide. And that's where the application ingested an encrypted file and used its own encryption engine in order to decrypt the data, process it, and then output encrypted output. There we go. That was our application level encryption. Now here's something new. This one is called transparent encryption. And this is where the encryption engine actually resides within the database system itself. So as it takes in an encrypted database file, well, guess what? It acts much like an application level encryption solution, because what it does is it uses its own encryption engine to decrypt that database file, and then it can use it. And this is called transparent because the user never has to interact with encrypting and decrypting files for this database to work, right? It just happens. It's like magic, but it's really just because we embed that encryption engine directly into the database system. And then once it's finished using that data and it wants to put it back, well, it just outputs it back as an encrypted file. And there we go, database encryption options. So we looked at our basic storage level encryption, then we looked at our volume storage encryption, dealing with volumes and operating system. Of course, our object storage, where we looked at like our Amazon S3 and our Azure Blob, and the ability we have to use file level encryption with that and application level encryption. And then lastly, of course, our database encryption options here. And really the new one we discussed was our transparent encryption, which was transparent because it was transparent to the users. They didn't have to do anything to make it work, which is super handy and very efficient, by the way, and helps reduce human error. So there we go. Infrastructure as a service, data encryption options. I hope this has been informative for you. I'd like to thank you for viewing. All right, it's time to talk about the importance of key management, and specifically encryption key management. And one of the jobs I had when I was in the Navy was managing encryption keys for our communications. And let me tell you, you don't want to mess that up, because when you're dealing with encryption, those encryption keys, guess what? They are your gateway into the data. If you lose the key, you lose access to your data. Not a good thing. If you allow that key to be compromised, if you post it out there on the web somewhere and everybody else can see it, well, guess what? They then could access your data potentially. Again, not a good day. So let's jump in and talk about the importance of encryption key management. So this is often considered the most challenging part of encryption. And yes, that is very true, because you cannot mess up. That's why it's so challenging. We've got to manage those keys. So what are we managing? Well, we're managing access to all of those encryption keys. We don't want the wrong person to have access to them. Wrong person. Who could that be? Well, I'll tell you, when we're dealing with the cloud, who manages the underlying infrastructure of the cloud? Well, our cloud service providers do, of course. Do our cloud service providers need access to our encryption keys? Well, here's the answer. No. Unless there is some special type of circumstances, they don't need access to our keys. We use our keys to protect our data. There is no reason for a cloud provider to be able to read our data. So, for example, we're talking about IaaS here. We spin up a virtual machine Does our cloud service provider need to be able to read the data within our VM? Well, the answer, no, not really. Because if they're doing something like backups for us through a service, well, they're going to be backing up the underlying files. They're not going to be backing up the individual unencrypted files in our operating system. They're backing up our encrypted files. Then they get restored, we can decrypt them, and we can access it. Now, there's always going to be some kind of, well, in this circumstance, they will need access to it. Yes, that is very true, and there might be a circumstance where your cloud service provider needs access to your data. However, the general rule of thumb is they do not need access to your data. Now, as another part of managing our keys, so of course we need to control who can access it, but part of this management is storing those keys. We've got to store them somewhere, right? Absolutely. And we need to ensure that we keep these keys as long as we have data that is associated with those keys. And where I'm going with this is data archival. We talked about data archival in a previous lesson, and we said sometimes you might need to keep that data for 6 or 7 years, or maybe longer in your circumstance. That means you've got to maintain the keys associated with that data for the same amount of time. That's a long time to manage keys for. You can't lose them. You can't destroy them. You've got to keep them intact, because if you lose access to the keys, you lose access to your data. And again, not a good day. Here's the other thing. Maybe you're storing some data for a while, and one of your keys somehow becomes compromised. Somebody posted it out there on the web accidentally, and it's been compromised. Well, at that point, you need to go grab the data associated with that key. You need to unencrypt the data, so it's back to plain text. You need to generate a new key, and then you need to encrypt that data with the new key, so it is then re-encrypted, and you're then going to store this key and manage it. Those are some of the challenges that we associate with key management. Now, some key points, pun intended. Loss of encryption keys. I'm going to put that in here. Loss of keys equals loss of data. And that's because if you lose your encryption key to your data, remember that encryption key, that is the gateway into your data. And if you lose it, you lose your gateway into the data, right? Unless you have a way to break that encryption, which if you're using encryption mechanisms that are up to standards, then you're not going to be able to break that encryption within a reasonable time frame. You've really lost access to your data. So keep that in mind. That's our first key point. Secondly, CSP, that's your cloud service providers. CSPs should not, N-O-T, capital N-O-T, triple underscore, should not be managing your keys. Now, can you store keys in the cloud? The answer to that is yes. There are instances where we will store keys in the cloud. However, that means we're managing them. They're simply residing in the cloud. The CSPs are not managing our keys at that point. We're still managing them. I just want to make sure there's a distinction between the two. CSPs should not be managing your keys. Very important. And of course, loss of keys equals loss of data. Now, we've got 3 primary options for storing keys when it comes to the cloud. Now, the first one is called internally managed. And this is where the keys are stored in our virtual instance or a VM or application where the encryption engine resides. So if we have a virtual machine that uses keys, it's going to be stored with it. If we've got an app that uses encryption, we're going to store the encryption key with the app. So that's where it's internally managed inside of our cloud resources, whether it's a VM or an application. Now, this is handy because it protects against loss of data due to loss of keys, right? If I store my key within my application or within my virtual machine, well, then I'm not going to lose that key and lose access to my data. So that is internally managed. That's our first one over here. Number 2, we're going to put over here. Number 2 is externally managed. And this is where keys are stored separate from the VMs and encryption engines. So just like internally was inside, external is external to our cloud resources. So if we have our VMs over here or app over here, well, the keys are going to be stored somewhere else. Now, of course, that does increase the risk of losing the keys and losing access to our encrypted data, and it does bring about a new challenge. We have to figure out, how are we going to ensure that our app over here and our VMs that use encryption keys can gain access to those keys? We got to make sure there's some type of secure way they can access it. So maybe we store those keys on premise at our offices on a couple of servers or something. Well, then that means we're going to have to ensure that when it comes time to access those keys on the server over here, that these apps and VMs can securely access it. And oftentimes we use a virtual private network or a VPN that provides an encrypted tunnel for us from our cloud environment all the way to on-premise, and this is a secure way to do that. Or we may store the keys in the cloud or in a separate cloud provider somewhere else. Either way, we need to understand there is a challenge associated with this, and that challenge is that we need to make sure, again, that those cloud resources needing access to the keys can still access those keys. That's very important to understand. And then lastly, we have number 3, third-party management. And this third-party management, well, is that a cloud service provider? They're a third party. Should they manage it? No. Remember, we just talked about this. Cloud service providers, yes, they're a third party, but they should not be who is managing our keys. Now, this is done usually through something called a key escrow, and this is a trusted third party that can hold our keys for us. And that trusted third party is not the cloud service provider. It's an additional trusted third party, and that is, again, called a key escrow. Very important. So that is some of the challenges and difficulties that we face when managing encryption keys, especially in the cloud. I hope it's been informative for you, and I'd like to thank you for viewing. We've been talking about data encryption. We've been talking about managing keys. And earlier I said that using data encryption was a way to protect the integrity of our data. Because if we can control who has access to it, then we can ensure that those without authorization, well, they can't access it and they can't mess it up for us, right? They can't tamper with our data. But there is another way that we can use encryption to validate the integrity of our data. And it shares the same name with one of my favorite breakfast items, and really any meal of the day item, hash. That's right. We're going to talk about using hash or hashing in order to validate the integrity of our data. So let's get started because I'm getting hungry. So validating data's integrity is so very important. It's the only way that we know data is authentic and usable and hasn't been tampered with. So how do we know if it's been tampered with? Well, we can use hashing, as I said. We can use the hashing process. So we're going to talk about how that works. It's pretty darn cool. All right, let's take a quick look at a scenario. You're going to generate an email, and this email consists of an invoice, and you're sending it to one of your customers, and they receive that invoice. Now, here's the question. How do they know that that invoice hasn't been tampered with in transit? How do they know for sure, 110%, no, let's not do that. Let's do 110% sure that that is accurate? Well, they could use hashing, because hashing can help validate our data's integrity, as I've said. Now, I've said it enough, and you're probably tired of hearing me say it, so let's talk about how it actually works. This is the hashing process. What we have here is our plain text. This is our original data. So what we do is we put it through a hashing process. And so we have here, we have our input. This is our original plain text data. We have the hashing process taking place here. And of course, we have an output. And that output is known as a digest. That is our output hash. And a hash is much like a data's fingerprint. It is a mathematical representation of that data. And it helps us to, you guessed it, validate data integrity. Now, here's the thing. This is not like encrypting and decrypting data. Totally different. This is very key. I want you to understand this right here. A hash is a one-way operation. One way only. One-way street. One way. In no way, shape, or form can this hash or this digest over here be unencrypted or unhashed to uncover or reveal the original data. That just is not possible. So to understand that, this is a way to create something that represents the original data. And this is called a digest or a hash. Now, hashing uses algorithms during this process here, and some common algorithms are MD5, SHA-1, SHA-2, there's SHA-256, SHA-512, and the list goes on and on and on. There's lots of different hashing algorithms that can be used. Now, here's the key. We now have a hash. So, if I was to take an email and send it with my original file, I go ahead and I send it to my customer, and I send along with it this hash I put in over here. Well, at that point, when my customer receives it, they could then validate the integrity of that invoice. But how exactly would they do that? Well, let's take a look at that right now. So now let's take a look at how we verify the data's integrity. So what we have here is the original hash of the data. This is my original digest. This is what I included in that email, my little digest over here. All right, so what the customer will do is take that invoice that was in that email, take that invoice, they run it through the same hashing process, all right, that one-way function, using the same algorithm. Let's say we used SHA-256. Well, it will create a digest. Remember, that's our hash, our output of the hashing process. That was our output here. And what they will then do is take the original one I sent, which is right here, and they'll take the one that they came up with, which is right here, and they compare the two. If they are equal, then the data is accurate. The integrity has been preserved. However, if they're different, then that means that this invoice file has been tampered with and is no longer valid. And that's how you can use hashing to check the integrity of data. So again, the hashing is a one-way function that creates a digest or a hash, which is a representative value of the original data. And then we can compare the hashes, and if they equal, then guess what? Our data's integrity has been validated. There we go. Validating data integrity using hashing. I hope this has been informative for you. I'd like to thank you for viewing. Encryption isn't the only way to protect sensitive data. That is right. You have other options, and they do have their places. Now, specifically, I'm talking about data obfuscation and anonymization. Now, these come into play mostly with compliance, and we're going to jump in and talk about that and why you might use it right now. So the question is, well, what is it and why do we do it? Well, data obfuscation and anonymization, basically what they do is they protect sensitive data. And we do it through generally some type of replacement process or creating a disconnect. Now, when it comes to data obfuscation, generally that is when we're doing some type of replacement. And when it comes to anonymization, that's where we're trying to create some type of disconnect between the owner of the data and the data itself. Now, I'm sure you've heard this before. You've watched movies or something, or TV shows. You're watching the show, especially in like crime dramas and stuff of days gone by, where you're watching it and they say, the story you're about to hear is true. However, the names and places have been changed to protect the innocent. Well, that's data obfuscation and anonymization at its finest. They're trying to create a disconnect, right? Trying to protect the innocent, protecting their information. And that's what it is and why we do it. So the end goal is to protect sensitive information. But is that it? No, we're also looking to protect privacy. And that's where the anonymization comes into play. And oftentimes we must do these to comply with regulatory standards and compliances, as I had mentioned. And we can also use this, specifically data obfuscation, to create test data. So we can take a production database, let's say, we've got a production database here, and we want to use it to do some testing. Well, the thing is, it might contain sensitive information. So what do we do? Well, we go in and we take out that sensitive information. We replace it with something else so that it's no longer in there. Then we have basically a clean database, meaning no sensitive data in there, and we can use it as test data. And it's going to fit the same standards as our production data, the same types of data included, same format length, and all these things. So it'll work within our systems, and we can use it for test data. So let's talk about some common ways to obfuscate data. So here we're concentrating on data obfuscation and some common methods. Now, number one, we have random substitution. Well, that's where we substitute data with random characters. So if we have a field in a database, this one here, and it contains sensitive information, well, what are we going to put in there? I don't know, just random characters that fit within the data parameters of that data field. So that's random substitution. We also have data shuffling, and that's moving data between fields. So we're moving data between fields in order to move data around. Then we have masking. And masking uses characters like a bunch of X's maybe to substitute for sensitive information. So if we had a sensitive information field here, we pull out the sensitive information and we just fill it with a set of characters like all X's or all A's or Z's or whatever we decide on. Next up is deletion. And that's where we simply delete the sensitive data from the field, or we might use a null value. And then lastly, tokenization. And I'm going to put it over here, tokenization. And it's not because I forgot to make a blue field for it. It's because this one requires a little more finesse, a little explaining. So let's look at tokenization. So here it is, tokenization. I want to talk about how it works. Now, this is where we take sensitive data and we replace it by a token value. Sounds interesting. So here we go. We have our production database over here. We'll put that there. There we go. So we'll put prod, so you know it's production. And we're going to say this blue piece of data is sensitive. All right, there we go. And then I'm going to have another piece to this. I'm going to need a token database. So here we go. This is on a separate system. This is my token database. Now here's how it works. I take this sensitive data here, and I'm going to put a token in its place. Token is 1, 2, 3, 4. And over here in my token database, I'm going to say 1, 2, 3, 4 is associated with our sensitive data. Now, anytime an application accesses this database and wants this sensitive data here, the production database is going to go to my token database. It's going to go over here. It's going to request that sensitive information. It's going to go back, and then the production database will provide that information to the requesting application. And that's how this works. But you might think, well, why even mess with that? What's the purpose of this? Well, here's the purpose. This sensitive data no longer resides in my production database. So this production database no longer falls within the compliance requirements for that sensitive data because it's not in there anymore. It's over here. And here we can put extra protection, extra precaution, extra security controls in place to protect it. And you might think to yourself, well, why don't I just do this over here in my production database? Here's why. In many organizations, you don't have a single production database, do you? No, heck no. Lots of places have lots of databases. And guess what? Those databases all reside in many instances within the same database system. And if I have sensitive data within one database on my database system, I have to protect the entire database system under whatever regulatory compliances are required by that sensitive data. So let's say it's payment card information, right? It's credit card information. Well, that means I have to have my whole database system PCI compliant. Whereas here, I could have a separate database system with this one database in it. It's much easier to protect this one system with one database than it is all of this other databases within this database system. You see where I'm going? We can actually manage the scope of our compliance with this. So by using tokenization, it helps us to reduce the scope and make our security lives a little easier. And that's where tokenization really comes into play. Now that has been our data obfuscation. Now it's time to focus on anonymization. Yes, it is hard to say, and we often flub it. So really, it's anonymization. Yes, anonymization. So let's talk about anonymization. So this is where we data de-identify or data de-identification, anonymization. Now, this is the process of creating a disconnect. And that's where I mentioned earlier using a disconnect. We change the names of the people involved and the names of the locations to protect the innocent. That is creating a disconnect. So if I was to watch one of those TV shows where they change the names and they change the location, it would be hard for me to identify who exactly they're talking about. And that's the idea that we're trying to do here. We're trying to separate data from the owner. And that's really what it comes down to. So we have data about the owner, right? Data about a person. And we're trying to create a separation between the two so it's difficult to link the two, to be able to look at some data and figure out who exactly they're talking about. That's the whole premise behind anonymization. So let's talk about an example. Maybe, how about a doctor's office? So we're dealing with a doctor's office here, and you have a person sitting in payroll, and they're dealing with creating medical bills or collecting medical bills, right? Let's say they're actually calling about collections. Let's put payroll collections. And this person over here working here, big smile, there we go, picks up the telephone and dials this person over here. We'll put a handset in their hand, there we go. And they pick up the phone, and here they've got a $20,000 medical bill, and this is what they look like. Of course they would. However, here's where I'm going with this. This user down here needs to understand the medical bill, the numbers associated with it. They do not need access to this person's entire medical history, do they? Absolutely not. They don't need that information. So by creating anonymization, we can separate data from its owner so that like this person can only see payment information and they can't see other information about this person. Hey, that's pretty darn great. That helps us to protect privacy. And that's what anonymization is really about, providing privacy. So you cannot take information about a person and associate it with them. That's what we're looking to do here, create privacy through anonymization. And that's data obfuscation and the hard to say word, anonymization. I hope it's been informative for you, and I'd like to thank you for viewing. Okay, do you like to lose things? Well, the answer is probably no. And I'll tell you what, I was on vacation a while ago. We were in Key West. We're in a hurry. We were in an Uber. It pulled up to our breakfast place. We got out of the car. There's this long line. And I reached my phone to come up with the plan B for breakfast. And guess what? I left the phone in the Uber. Not a good day. We did get the phone back at the end of the day, but it made for a rough day, let me tell you. I don't like to lose things. Nobody likes to lose things, and especially when it comes to sensitive data. We definitely don't like to lose any of that. So let's jump in and talk about data loss prevention. So, data loss prevention or DLP systems. Now, these are pretty darn cool. These are controls that we can put in place to help ensure that data does not leave our environment if we don't want it to. And we need things like this because people, guess what? They make mistakes. We do all the time. I left my stinking cell phone in the Uber. Now, if that's not a mistake, I don't know what is. So we might accidentally send some sensitive information out via email or via a file upload, and it's unencrypted. Ooh, not good, right? Well, we can help prevent that. DLP systems can prevent these things from happening. So let's talk about the three components of a DLP system, data loss prevention. Now, first of all, the first component is discovery and classification. So in order for a DLP system to actually prevent data from leaving an environment, it's got to know what data to look for. We have to tell it what data do we want you to prevent from leaving the organization. And then we have to go and discover that data. And we have to tell the DLP system to act on this specific classification of data because it has to be able to recognize that data. And generally, when we go through a data discovery and classification process, we're going to tag or label the data in its metadata in some form or fashion, right? And that way, when the DLP system sees a specific label or tag, it knows, hey, this isn't supposed to leave the environment. I should probably prevent this from leaving. There you go. So that's the first component, discovery and classification. Now the second component is monitoring. The DLP system generally sits at the edge of the network so it can monitor all data coming and going from the network. So if we have our internet connection here, we generally have a firewall at the edge somewhere and maybe an intrusion prevention system. Well, when that comes in, we're going to need to place a DLP system here in line. It has to be in line so it can block communications, and we're going to talk about that. And then it comes in or it goes out, right? So this DLP system can monitor all the traffic coming and going from the network. And then lastly, enforcement. And this is where the P in data loss prevention comes into play. The system can actually block communication containing sensitive information. So when it's monitoring that network traffic over here in our little diagram, if it sees an email trying to go out with a certain classification of data in it, well, guess what? It can actually enforce this, and it can say, nope, your email cannot leave the organization. Same thing goes for file uploads or any type of transmission of this data across the network. It can actually prevent it from leaving the organization. And that's the whole idea behind a data loss prevention system. Now, let's talk about DLP systems in the cloud. A little bit different. Now, when it comes to data discovery and classification, that can be a little bit difficult in the cloud because oftentimes data is widely dispersed in cloud environments. So you could have some over here at this data center, might have some over here at this data center, some at this data center. You see where I'm going with this? We need to keep track of our data. And that's something we should be doing anyway. You need to know where your data is at all times when it's in the cloud, where it's being replicated to. And this is very important. And it's kind of one of the challenges of having data in the cloud, and especially if you want to use a DLP system, you got to know where your data is. Another thing is that when you're using DLP systems, they're analyzing all that data. Remember, they're analyzing and monitoring all the data coming and going from your environment. They have to be sized appropriately. For example, if you have a 1 gigabit connection going to your DLP system and then out of your DLP system out to the internet, right? If your DLP system can only process 100 megabits of data, you've got here 1,000 megabits of data. That's a gigabit. So you got 1,000 megabits. It comes to a screaming halt, right? You hear the brakes slamming on as it comes to a slow 100 megabit through here, and then you get back to gigabit speeds. But what do you see here? Well, let me draw it out for you. You go like this, and then down to there, and then up to there. If we do the same thing on the other side, this, my friends, is, that's right, a bottleneck. And that's something we need to avoid when implementing DLP systems. And that's why we have to make sure that they are sized appropriately. Because over here we had our gigabit, and then down here we had our 100 megabit, and then our gigabit over here, of course. So there you go, bottlenecks. Make sure that we are properly sizing our DLP systems. And that's not only in the cloud, that's also on premise. Now, something else to consider, you may need to get approval from your CSP before implementing a DLP system. And that is something you want to check on. Some cloud providers require approval for something like that. Others don't. So just keep that in mind, and you'll want to check on that. And lastly, when you're in the cloud and we're dealing with data replication, this is good practice. We want to replicate our data from one data center to another data center so that we have survivability, we have backup, right? Well, the thing is, if you have a DLP system right here and it's trying to look at all that data coming and going, well, it might be blocking some things it shouldn't be blocking, which would cause your data replication to be inaccurate or incomplete. So you need to make sure if you're using DLP systems and you're performing data replication, that your DLP systems are allowing all the replication data to pass and it's not blocking that sensitive data, because in the event of an emergency and you need to fail over, guess what's not going to be there? That's right, your sensitive data. And that, again, makes for a bad day. So let's talk about, lastly, DLP policies. Now, we talked about examining your DLP system is sitting out there. It's got the big eyeball, and it is going through and it's examining, monitoring, analyzing all your traffic that's coming and going through your network. You got to have policies out there. These policies are the rules that say what traffic or what data should be blocked. And the thing is, this DLP system, these rules over here, well, these rules need to align with something. Well, that's right. They need to align with your organizational policies, because this is what's going to put the policies into play. It's going to take action to enforce these policies. And specifically, we're probably going to be talking about a data handling policy, because that's where we're going to be talking about different classifications of data and what you can do with certain classifications of data. So our rules should definitely align with our organizational policies. And again, specifically the data handling policy. And that's the world of data loss prevention and how it can help us to prevent data loss, and more specifically, our sensitive data. That's what we're looking to prevent from getting out of our organization if it's not supposed to leave. And there we go. Data loss prevention. Again, don't forget your cell phones in the Uber. Not a good idea. Don't allow your sensitive data to escape your organization if your policies do not allow for it. And that, my friends, is data loss prevention. I hope this has been informative for you, and I'd like to thank you for viewing. A huge part of information security is protecting data. Data is very valuable to our organization. It's an asset that we protect. But I have a question for you. Can you adequately protect your organization's data if, number one, you don't know what data is out there, and number two, where that data is located? Well, the answer is an astounding no. You can't. If you don't know that something exists, then how can you protect it? Well, you can't. And that's why we are about to discuss the process known as data discovery. So, in order to protect our data, we must first know what data we have and, of course, where it's located. It's those two things that come together that allow us to understand what data we need to protect. And it's very important that we perform data discovery in order to identify this information. Because again, if you are an IT professional and you have the job of protecting data within your organization, protect, Well, again, you can't protect it if you don't know it exists. So let's say, for instance, you have a department, maybe an R&D department, and they're working on some top secret project, right? And they don't tell IT that it exists. And they decide to put it over here on this server that hasn't been used for a long time. It's an old server, but it's kind of out of the way. And if IT doesn't know it exists, the question is, how can we properly protect that data? Well, the answer is we cannot guarantee it will be properly protected. And that's why it's so important that we perform data discovery. So let's talk about 3 different activities that are a part of data discovery. Well, number 1, we need to create some type of inventory. That is very important. We need to inventory what data that we have as an organization, and of course, where that data is located. And something else that's very good to put into this inventory when we're talking about different types of data is the classification of the data that we're inventorying. That way we can quickly identify where certain classifications of data reside. It's a great way to get a quick snapshot, kind of like a dashboard view of where our data resides. Now, another type of data discovery activity, which is a little bit different, is known as e-discovery. Now, e-discovery is when we are responding to some type of crime or incident and we are collecting electronic evidence. That is what e-discovery is all about. Not just finding all the data that resides in our organization, but specifically evidence within our organization, data that pertains to a crime that has taken place. And that process is known as e-discovery. And then lastly, we have data analysis. Now, data analysis is where we can really pull some value out of our data. Now, our data has day-to-day value in it, but we can get more value out of our data by performing some additional analysis. Sometimes this is also known as data mining, and that's where we're looking to pull information from our data, infer some things from the data to gain that additional value and insight into our organization. Now, when it comes to our data discovery, there's really 2 main types of data that we're going to be dealing with. Now, the first one is known as structured data, and structured data is usually structure in the type of a database. So oftentimes we refer to SQL data as a structured data, and that's because it's maintained in a certain type of format. When we're talking about databases, we're talking about tables. This would be known as a table, and you've got rows of data and columns of data and individual cells of data, and there's a specific format that's followed to create this data structure. But then we also deal with unstructured data, and unstructured data, well, that's a little bit different. It uses an unstructured format, like some type of file storage area, such as, in the cloud, we're dealing with Amazon S3 is an unstructured format, and Azure's Blob is another example of that. And this is unstructured because it's really a bit different. And those are the 2 primary types of data that you will run across when performing data discovery. And those activities are very important. Again, we want to go out there and we want to create an inventory of our data so we know what is out there and where it's located so we can properly protect it. And we also might perform some e-discovery. If there is a security incident and a crime involved, we're going to go out and we're going to discover evidence associated with this crime. And then, of course, we're going to perform our data analysis on our data so that we can pull some additional value out of our data. And that's been data discovery. I hope this has been informative for you, and I'd like to thank you for viewing. We're continuing with data discovery, and we talked about why it was so important that we do data discovery, and we talked about some of the components of the process itself. However, there's more to it. There's techniques we need to discuss, and guess what? There's also those things that you need to watch out for. So let's jump in and continue with data discovery. So let's start off by looking at 3 data discovery techniques. And really, what we're talking about is 3 different things we're analyzing. Now, the first one is metadata. Now, metadata is information about a file or about data in particular. And this is information about it, as I said. Things like permission, size, location, the owner, date created, date last accessed or edited. So it's information about a file. And this is information that can help us better understand what type of data we're dealing with. Now, secondly is labels. And these are things like keywords that we can assign to a file and actually can become part of the metadata. And these labels can be things like the classification of data, which is super handy to go ahead and label that. That way the systems can understand the labels. They can look at the label and you can create rules within your systems that say do certain things with certain classifications of data. And as long as you have a label of a classification assigned, then you can actually do that in some systems. The other thing you might find as a label is the owner or the department that it belongs to. Those can also be labels. You can have more than one label. And then something else we're going to analyze is actually the content. So we're analyzing the content of the files or of the data. And specifically, we're looking for keywords. And these will help us to identify certain types of data. For example, if I find a file with a bunch of social security number formatted data in it, well, there's a good chance that this is some sensitive information like personally identifiable information or PII. We might find some information with invoice numbers, so that would help us know that it belongs to billing or accounting. We can go through and look for specific terms like healthcare terms to identify PHI data, protected health information. And it helps us to identify these different types of content and classification simply by analyzing the content looking for keywords. So those are 3 of the things that we would actually analyze or look for within data to help us identify what it is and what it's used for. Now, why else do you think we might want to perform data discovery other than for simple inventory? Well, we might want to classify data or identify sensitive information. Because if we can identify this sensitive information through data discovery, it's going to help us. Because at that point, when we create our inventory of the data, we can assign a classification based on the sensitivity of this data. For example, is this protected health information, PHI, dealing with personal medical information? Or is this PII, personally identifiable information, things like driver's license numbers, date of birth, social security numbers, things that help you identify individual people. Or maybe it's dealing with credit card. It's got PCI DSS information in it. So here we're talking about credit card transaction information. Or maybe it's actually got information about students, like grades and classes they're attending and information like that. And that would be information protected by FERPA, which is the Family Educational Rights and Privacy Act. So you'll see here we're looking for different types of data, different classifications of data. And that's another great reason to perform our data discovery, because now we can analyze this data, identify if it is sensitive, and if it is, we can put controls in place to protect that data and meet our compliance requirements. Very important. And once we find these different types of data, well, it's a good idea that we go ahead and put labels on our data. And that's another reason we would want to perform data discovery. Now, there are issues when it comes to data discovery, believe it or not. And the first one is poor data quality. Now, if you have a bunch of data and you're performing analysis on it, and there is very little metadata, there's no labels, there's no categorization, no standard formats, well, that's pretty poor data quality, and it's going to make it more difficult to perform the analysis during our data discovery. So that's the first issue. Now, the second issue is hidden costs. And this can really come in a couple different forms. First of all, you might use some type of application in order to perform your data discovery to help you streamline it, at which point you may end up with some seriously pricey licensing in order to automate this data discovery. So that is a hidden cost. Another one, if you're working in the cloud, well, when you are dealing with the cloud, let's put a little cloud up here, and you're putting data into the cloud, generally that's free. They don't charge you for putting data into the cloud. However, when you go putting data out of the cloud or moving it out of the cloud, well, then there is generally some type of charge. Now, it's not a lot until you get to moving a lot of data. So here, if we were on premise and we were running a data discovery application here on premise, let's say from a computer over here, and it was going out to our cloud and it was doing some data analysis. Well, sometimes these data discovery applications want to pull down a copy of the data they're analyzing to analyze it locally, and then it will put it back when it's done. Well, guess what? If you're analyzing terabytes of data and you're pulling it down over a couple week period or a month period, you're going to be paying for that data leaving the cloud. So that's something to keep in mind. That is another hidden cost. So these have been some data discovery techniques and issues that you might run into. So keep these in mind as you begin your data discovery adventures. I hope this has been informative for you, and I'd like to thank you for viewing. All right, now that we've gone through and we've discovered all of our data and we've recorded it, we know where it's at, we are ready to start protecting it. Well, it's time for the next step in our data discovery and management process, and that's going to be classification. We've talked about classification some already, but now it's really time to get down into the nitty-gritty of classification. So let's get started. So, implementing data classification, very, very important. So once we've gone out and we've discovered all of our data and we analyzed it and we know what data we have for sure, we have the data. All right, that's our starting point. And now it's time to take the next step, which is implementing data classifications. Now, in order to do this, it comes down to one word: policy. We need a policy that's going to define the categories that we're going to use, the labels we're going to use, and how we're going to treat certain types of information. So our policy is actually going to work in a way that's going to do a couple things. Number one, let's put it over here. Number one, it's going to define our data classifications. All right, so this could be something like, let's change colors here. Let's go, let's say we do public. Public is one classification. That's information we can send out to the public. Another one would be internal only. There we go. Only. There we go. And then maybe a third one we have is labeled as sensitive. There we go. So those are the three different types of classifications we have. Now, what's the purpose behind having a classification? Well, the purpose is really twofold. Number one, it is to identify a type of data. All right, so now we can identify a type, but why would we even care about identifying a type of data? Well, here's why. Two, how are we going to handle that type of data? That's very important. Just think about it. In the movies, when you see the confidential and secret and top secret, well, those different types of data are handled differently. The top secret is, of course, guarded the most. So there are more security controls around it and who can see it. So that's the whole idea here. We really want to have a way to identify data. So if I see a file over here, I can actually look at the file or the metadata within the file and identify the classification associated with that file. That way I can take that knowledge and I can say, oh, it's a top secret file. Well, now I know how to handle that top secret file. If I don't have a classification and I just have a bunch of files out there, a bunch of data, well, how do I handle that data? Can I share that with someone like a business partner? Well, maybe, maybe not. And those are the types of questions that data classifications help answer. That's why it's so important to have them. So now we have classifications. Let's separate that there. So we had classifications was number one. But secondly, our policy is also going to define labels. Now, labels are the words we're going to use to associate a classification with a file. In my opinion, I would use the same words: public, internal only, and sensitive. Those would be my labels. However, the idea of having labels allows us to use different words. Maybe we want to call public blue, and internal only red, and sensitive whatever color that is, orange, yellow. But the idea is you don't have to use the same word of the classification to use as the label. You can use whatever you want as long as you define it in your policy. But in my opinion, use the same words, because remember, we need to keep things simple. We don't want to confuse people. If it says confidential, it's confidential. If it says public, it's public. If it says internal only, it's internal only. There's no confusion. Just keep it simple. It's always better that way. So that's what we're dealing with when we come to policies. We're identifying basically our classification. We're also going to identify our labels. And one more thing, number 3, this right here. How are we going to handle the various classifications of data? Because if it's internal only, it cannot leave the organization. If it's sensitive, only certain people can access it. If it's public, well, that's information we can release to the public, things like marketing materials and that kind of information. So that is data classification in a nutshell. But here's a question for you. Who's responsible for classifying and labeling data? Here's the answer: the owner. That is right. And this is who's responsible for labeling. Yes, but it's also, I'm going to put an also up here, also data classification. And sometimes labeling and classification can be used in place of each other, but the idea is when it comes to classification, we're going to assign a label. And the owner is who's responsible for making sure this gets done. That is very important to understand, the owner. So if you create some data and you're the owner for that data, you are responsible for making sure that it's properly classified and labeled. And now that that question's been answered, we need to talk about applying data classification labels. Now these labels can be applied as metadata within individual files. And by using the metadata labels, we can have the systems be able to identify the classification of individual files, things like data loss prevention systems that we've talked about. And Microsoft has actually created something called the Data Classification Toolkit. And this is used to identify, classify, and protect data on Windows servers. So it allows you to put your labels on your data, and then you can create policies about what happens with the data that has these specific labels. Just what we've been talking about. Except you can actually do it on your Windows servers through the Data Classification Toolkit. So it's something that you might want to look into. And now that we've discovered all of our data and we've properly classified it, we actually need to now do some data mapping. Now, data mapping, it's like the inventory we talked about. We just need to record some information about our data. Number 1, we need to have its location so we know where it's at. We can verify that it's being protected properly. We want to know the data format that's being used. We want to understand the file type that's being used. We want to understand some other things like the location type. Specifically, is this a Windows volume? Is it a database? Is it in cloud file storage? And then lastly, we definitely want to know its classification of that data. So there we go. Those are the things we're looking for because we need to know where it's at so we can protect it. Knowing its format and file type are important because over time, guess what happens? Well, the applications change, environments change, file types change, and some of these may no longer be supported. So when we go to access something that's been in archives for a few years, it's very helpful to understand what its format and file type are. And then the location type can help us to understand, is it in the cloud? Is it on premise? Is it on something that can be encrypted or not? And of course, classification. Enough said there. So that is our data classification. And again, it all starts with a policy. And from there, we can create our standardization within the organization, which folks can then follow. The owners can follow those policies to assign proper classifications. Our users will understand what they can and cannot do with data. And hey, now we have data management in action. I hope it's been informative for you, and I'd like to thank you for viewing. Protecting data within our own environment is something that's very manageable, right? It's in our network, it's in our file systems. We have control over the permissions and the controls surrounding the data in our environment. But what happens when we send those files outside of our environment? Well, how can we protect them at that point? Because they're not in our environment anymore. They're not on our file systems anymore, right? They've left, and they left behind it all of the permissions that we set for those files when they were in our environment. So, what do we do about this? Well, it brings up something called Information Rights Management, or IRM, and that's what we're going to talk about right now. So, what is IRM, or Information Rights Management? Well, it is a technology, and it's used to protect data by adding independent access control directly into the data itself. So, within a file, it allows us to embed security rules within a file. That's pretty interesting because, as I said, when we have data in our environment, let's say at our office or in our data center on our servers, we can protect that data. We can create access control lists and access control entries. So these are rules of who can access what in our environment. But again, once we send those files outside of our environment, they're no longer part of our file systems internally, part of our servers and our network. They're out in the wild at someone else's environment. And we don't have control over this environment's access control lists and entries and firewall rules and system permissions and all those things. So that's where IRMs come into play. They create an additional layer of access control outside of our environmental controls because we're able to embed those controls and rules directly into those files. So when they leave, they take those rules with them. And that is what's so darn cool about Information Rights Management, or IRM. Now, IRM can not only protect your standard files, but also can protect things like emails, web pages, and various other types of data, such as databases. And IRM is often used interchangeably with DRM, which is Digital Rights Management. And if you've ever dealt with DVDs that you've used or that you've purchased online, or maybe audiobooks that you've downloaded, a lot of times you'll run into DRM, where you have to provide some type of authentication before you can open the audiobook or open that video file and watch it. So that's what IRM is in a nutshell. Now let's talk about data rights. Now, data rights is controlling who can access your data. It's pretty darn simple. Data rights. Who has the rights to access your data and do things with it, like write to it, make changes to it, save the file, open the file, right? It's all about who can access the data. Now, as part of those data rights, and that's what we're dealing with Information Rights Management, we're creating the rules for who can do what. Well, there is a couple things we need to do. Really, we need to put it through provisioning, and this is our data. All of our data, as part of an IRM, has to go through a provisioning phase, and there's two steps. The first step is that we must ensure each piece of data is provisioned with an access policy. So we really need to apply access policies to our data. And that access policy is a set of rules. So if I have a bunch of data up here and I want to make it part of my IRM system, well, I need to apply a policy to this data. And that makes sense, right? In order to have rules apply to something and work, you have to physically attach them or apply them somehow to that something so that they can work. All right. And then secondly, each user that wants to access this data up here, well, guess what? They have to have an account provisioned for them within the IRM system. And that's because this IRM system, with its settings, its rules and policies, well, those accounts are outside of our standard infrastructure. Because remember, when we dealt with our internal file systems and servers that we had data on, well, we have accounts on these systems internally. But when these files that we're dealing with, when we send those outside and they have the IRM protection as part of the file, somehow we have to have a way for whoever is wanting to look at this file or do something with it, we have to have a way to authenticate that user. So they need a user account and a password so that we can authenticate them. Now, along with all of this activity, we see comes overhead. And this is administrative overhead that's part of the IRM system. So many systems allow a type of auto-enroll process, especially when it comes to user accounts. So that is something that you should keep in mind if you're looking at using IRM. Now, as it comes to setting up these rules, we really come down to three types of access models. All right, we have the first one, which is mandatory access control, or MAC, M-A-C. And mandatory access control grants access based on specific labels. And these labels could be things like classifications. This should be secret, confidential, internal only, public, all of these things. And this is, I'll put a star here, the most restrictive type of access control. And that is mandatory access control. And again, it's based on labels. And these labels can be classification. Next up, we have role-based access control, or RBAC. And role-based access control is granting access based on the user's role, or whatever their position is. So if they're part of the accounting department, they get access to the accounting file. So it's all based on the user's role that they have within the organization. Then we have discretionary access control, or DAC, D-A-C. Now, this is where the system or data owner gets to decide who has access. So it's up to the discretion of the system or data owner. And those are the three different types of access control models. And again, mandatory access control is the most restrictive type, and it's based on labels. We have role-based, based on your position or role within the organization, and then discretionary access control, where the data or system owner gets to decide who gets access to the data. So now we've got a question. We've talked about IRM. We see what it is, but here's the question, and here's what I like to know about various technologies. Well, how does this thing work, right? That's what I want to know. Well, here's how it works. So we have a company, we're going to call it Company Blue, and Company Blue over here, we've got Fred over here. Fred is creating a file. There we go, and he's created the file. Now, Company Blue uses an IRM system, and we're going to say it's up here. It's an IRM cloud-hosted system. So we're going to have our IRM up here in the cloud. Now, Fred's going to apply IRM rules to this document. Now, they're embedded in the document. And Fred is working with a business partner over here. This is Company Red, if you hadn't guessed. And over here, we have Sally. And Sally works at Company Red. And Sally and Fred are working on a project together. So what happens is Fred creates this file, attaches some IRM policies, and then Fred needs to make sure that Sally has a user account set up in the IRM. Now, he can send an email oftentimes to Sally with a link to the IRM system so she can self-register and create her own user account and password, and that's fine. But Fred needs to make sure that Sally's user account has rules associated in this file. Then, this file is encrypted and sent over to Sally, probably via email, and then Sally wants to open up this file. So what she does is she clicks on the file, and it either takes her to a website to authenticate, and this website would be up here in the cloud, or it might open a window and prompt her for credentials, and these are the IRM credentials. Once she provides those credentials, she can then access this file. And that's how IRM works in a nutshell. And sometimes users will need to install some type of application plugin in a web browser or install a little application on their computer so that they can access the IRM files. They work differently, but this is pretty much it in a nutshell, so you can get a better understanding of how it works. Now, guess what? There are some really cool additional IRM features. Not only can we control who can access data, we can control what they can do with it. And this is some cool things other than read, write, and execute. What can they do with it? We can control their ability to copy and paste the information from the document, so maybe they cannot actually copy data from the document. We can disable their ability to take screenshots of the document. So if they do a screenshot of the document, it would be all blurry and they couldn't read it. We can also control the ability to print the document. So if they wanted to try to print from it, well, it just won't allow them to. And these are some additional IRM features that are very handy when it comes to controlling your data when it leaves your environment. And these are things that IRM can provide to you. Not only who can access it, but what they can do with it in their own environment. And that is IRM in a nutshell. I hope this has been informative for you, and I'd like to thank you for viewing. When it comes to data protection, well, we oftentimes have to retain data for a certain period of time. We have to hold on to it because of regulatory compliances. Well, we also have to make sure that we properly destroy the data when we no longer need it. So we really need to concentrate and focus on retaining our data and proper data destruction. So let's jump in and talk about them. So data retention policy, that's what we're talking about here. We're talking about data retention. We got to have a policy surrounding it. We're talking about data deletion. We got to have a policy surrounding that as well. So when it comes to data retention policies, what will this define? Well, of course, it's going to define a retention period for various types of data. So if it's saying you've got HIPAA data, you have to keep it for X number of years. If you have PCI related data, you have to keep it for X number of years. If you have some type of other regulatory related data, you have to keep it for X number of years. Well, that's the thing. And that's one of the reasons we need to classify data. Remember, we talked about adding labels of classification to data. And the whole idea is so that way, when it comes to things like data retention, it's easy to identify that data and make sure the proper rules are in place so that we are retaining that data for a specified period of time. So not only do we have to retain it for a certain period of time, and that should be defined within our data retention policy, we also want to determine the retention formats. So when we're dealing with specific types of data, we want to make sure that we save it in specific types of formats. So that way we can always access it later on, especially if it's something that is a proprietary format and we have to do some type of exporting of this data. Well, we need to determine what kind of exported format we would want to do that in. Then next up, data classification. And this defines how all the classified data should be stored based on its classification. So if we're retaining it for a period of time, should it be encrypted? That is a question that needs to be answered by the data retention policy. We also need to define our archival and retrieval process. And by having this process in place, we're going to come up with some detailed instructions that tell us exactly how we're going to archive our data for retention and how we're going to retrieve it when we need to perform a retrieval. So we need detailed instructions on how we're going to do that. And then lastly, we need policy review and enforcement. And this is defining the period at which the policy will be reviewed and who's responsible for enforcing the policy. And this really goes for every policy. You should have some type of annual or semi-annual review that is done to make sure that that policy still meets your company's needs. And of course, we've got to have enforcement. If it's not enforced, there's no accountability. And if there's no accountability, policies are not going to be carried out. So there we go, data retention policies. Now, we need to look at data deletion procedures and mechanisms. So when it comes to data deletion and proper data deletions, well, we've got on-premise, and then of course we've got in the cloud. These are different because we have access to physical hardware on-premise. So if we're talking about proper data destruction, well, we can do physical destruction at this point. If we have hard drives and we want to destroy them, put them in a shredder, hey, that's physical destruction. We can do that. If we have hard drives and they're spinning disks, not SSDs, but spinning disks dealing with magnetic fields, we can use degaussing. And again, it does not work on SSDs. So we'll put a circle and a line through SSDs. Again, not working on SSDs because SSDs don't rely on the magnetic field. All right, well, what's some other ways we can destroy data? Well, we could overwrite data with multiple passes. So we'll say multi-pass overwrite, which that's not the best solution, but we could also do crypto shredding that we've talked about before, or cryptographic erasure as a proper name. All right, that covers our on-premise, and really the difference between on-premise and the cloud. On-premise, we have access to the physical hardware. That's right. Now, in the cloud, really there's only one good option, and that is crypto shredding. And again, the proper name for this is cryptographic erasure. And of course, lastly, you definitely should have a data disposal policy in place that outlines whatever procedures you're going to use in these various locations. And that is data retention and deletion. I hope this has been informative for you. I'd like to thank you for viewing. As part of data management, we will need to hang on to data and retain it for a certain period of time based on that data, specifically what type of data it is, what type of regulatory compliances are associated with that data. But the thing is, we don't have to keep this data in our production environment forever. No, there's a point in time where we no longer need this piece of data for production. However, we still need to hold on to it, and that's where data archival comes into play. So let's spend a little time talking about data archival. So what is it? What is data archival? Well, it really comes down to identifying inactive data. So this is data that we no longer need for production, so why should we keep it in our production environment? Well, the answer is, well, we don't have to. We can archive this off. Now, of course, we need to keep this data for a set period of time. And again, as I said, this depends on the type of data it is and what type of regulatory compliances that we're dealing with it. So maybe we need to keep it for 7 years. Well, guess what? 3 years into this data's life, we no longer need it in production. So we need to keep it for another 4 years. So what we want to do is archive this off for 4 years. And then at that point, we can properly destroy it when we've met the regulatory compliance of holding and archiving this data. So before we can do this, we need something. And we've talked about these before. I said this is a very important thing, right? It helps identify what our organization's stance is and what we should do in certain instances. So, of course, that should lead you to policies. So here we go, a data archival policy. So what should a data archival policy include? Well, it should include encryption procedures. Absolutely, because with long-term storage and archival, that means we have to manage those encryption keys for that same period of time. So if it's for 7 years, we have to maintain these keys for 7 years. And if you lose your keys, you lose access to your data. We also need to make sure that we're keeping track of where data is located. So data tracking. We've got to make sure we know where it is at all times, as we've said multiple times throughout this course. We also need to consider data formatting. And we actually talked about data formatting in the last video when we were talking about data retention. It's important to understand what formats that your data is kept in. It needs to be documented. We also need detailed data restoration procedures. And that way, if we do need to restore data for some reason, maybe an audit or something, well, we have procedures and detailed instructions on how to do just that. And these are the 4 key points that our data archival policy should include. Now, there's something else I want to talk about, and it's called legal hold or litigation hold. Now, this is a type of archival or data retention, but it's outside of our standard data retention or data archival policy. And here's what legal hold is. If there is litigation in play with your organization, meaning some type of legal action, or there's a case going on in court, well, your legal team is going to notify you, or IT, basically management, that you have a situation, there's litigation going on, and you need to perform a litigation hold or legal hold. They're used interchangeably. And this means that data destruction activities associated with any type of data that's part of this litigation, well, guess what? It can't be destroyed. You have to suspend your normal data destruction activities because of this litigation that's going on. And if you do not comply, your organization does not comply with the legal hold, they can be found guilty of something called spoliation. And spoliation is the action of ruining or destroying something, and that's what you did. If you went through and destroyed something that was in legal hold, you are guilty of spoliation. And that's what legal hold is all about. And it is a type of data archival. It's where you have to hold on to it because of litigations that are going on that your organization is involved with. And we have to suspend all of our normal data destruction activities for data associated with that litigation. And that is data archival. I hope this has been informative for you, and I'd like to thank you for viewing. When it comes to managing your data, how do you know what's going on? How do you know what's happening with your data? Who's accessing your data? What users? What are they doing with it? Well, the answer is logs. Logs tell us all the things. They tell us everything that's going on within your systems, who's accessing your data, what they're doing with it, and just good general system knowledge in general, like errors that are happening. And it's great for auditing. When you want to audit what's going on in your environment, we turn to the logs. So let's jump in and talk about those logs. So let's start off by defining a data event. What is a data event? Well, it's when something happens in your environment. And when we're talking specifically about data, it's when data is created, absolutely. When it's edited, absolutely. Well, what about when it's deleted? You better believe it, it's logged. Anytime anyone accesses data, it's logged. So all these events, well, they create data events. And with data events come event attributes. And these are the attributes or pieces of data or data points associated with an event. Things like a timestamp. When exactly did this happen? Date and time. When did it happen? It's very important to know because when we're auditing events, we need to know when it happened. We might see an event ID, and this is a specific ID number associated with a type of event. Like in Microsoft Windows, we often see event ID number 4625 is when someone fails to log into the system. So that's something that we see often because people typo their passwords and things. So that is an example of an event ID. We also see IP addresses. So when there's network communications involved, we'll see the addresses involved. We'll see service names. So if there are service names associated with the event, like a service starting up or a service stopping, we're going to see a service name. You'll see account names. So when a user logs in, well, we're going to see an account name. When a user fails to log in, like in this up here, we're going to see an account name. We're going to see descriptions. And descriptions are where we're getting the intimate knowledge of the event that occurred, right? We're getting a message like user failed to log into system or something along those lines. Now, if there are URLs involved, we're going to see URL information. So if a user tried to access a specific URL on, let's say, an IIS server and Windows server, well, and there was an event involved, then that information would be involved, that URL information. We're also going to see any error codes that might be associated with the events on a system, and maybe even a severity level. Because if this is a critical event, we want to know, so we're going to have a security level associated with it. So when we have an event and we're looking at the logs, we're going to see a bunch of this information, these event attributes. Now, when it comes to the cloud, what are some of the event sources that we're going to be able to pull logs from? And a source is somewhere that we get these event informations from, these logs. Well, let's talk about software as a service. Now, here we're going to be able to access the application logs, most likely. There's going to be some type of application logs that we can access to look at. Now, this won't be the deep, nitty-gritty, dirty, down and detailed logs. These are going to be things like user activity logs. So we can see what users on our account are doing what in the application. And that's probably pretty much all you're going to be able to get out of a SaaS environment. Now, when it comes to a platform as a service or PaaS, since your organization is the one who built it, they can pretty much decide what type of logging capabilities are going to be available. So at this point, it's going to be your choice within the app. You're not going to be able to see the underlying platform logs. That's just not going to be available. Then when we look at infrastructure as a service, we got a lot going on here. We have virtual machines. So what we're going to have is we're going to have VM OS logs, like our virtual machine Windows or Linux logs. They're going to be there. We might be able to get some network captures from our devices themselves to see what's going on. We might have a virtual firewall that's running in our environment, and we might be able to access those logs if we spin up a firewall in the AWS or Azure or whatever cloud provider we're using. If we spin up a virtual firewall, we'll be able to access those logs. There's DNS logs that we might be able to access. That would be very helpful. There's also going to be things like billing records that's going to be in there as well, based on what resources that we use, and that's going to be available through the management portal. So those are some different event sources available to us in the various types of cloud services. Now, here's the thing. When it comes to audibility and analysis, there's lots of data sources that are out there. And we just looked at some of those data sources available to us in the cloud. So what you need to do when it comes to the cloud, you need to figure out what you need. So think about this. When you're using your on-premise systems, what do you need from your on-premise systems as far as logs for audits? That's a good question. For your SIM to ingest and check for security events and the ongoings of. And you need to identify, what do I use on premise? Then you need to take that and you need to figure out, do I have this in the cloud? If I do, great. If I don't, what are my options at that point? And that is very good to know. You need to know what your options are, because many cloud providers provide above and beyond security, logging, and resources, but they come at a cost. Here's the thing. You need to know what you need. If you don't know what you use already, then you're not going to know what you need. So it's going to be kind of hit and miss when you're getting up and running in the cloud and you're logging. Now, if you're starting out from scratch in the cloud, well, what you need to do is look at what you have and then kind of figure out what would you like to see, and then go find out what options there are for that. And of course, what it's going to cost, because we need to budget for our security needs. And that is logs and audibility, and what you should consider when it comes to the cloud. I hope this has been informative for you, and I'd like to thank you for viewing. In the last video, we talked about logs and log events and log sources and all the logs. Not the Lincoln logs, though. Those we left out. But when it comes to logs, we need a place to store them. We need to understand how much logging activity we're going to have, how much storage we're going to need, and we got to figure out where we're going to put them. So let's talk about that right now. So where are we going to store all these logs? That is the question. Well, first of all, we got to understand, well, how much log activity do we have? And then we need to figure out, how long do we want to keep these logs for? So log activity and how long we want to keep them for. And here's why. So if I've got a server, here we go, and I got one Windows server, we'll start with that. And we let it run for a few days, and I take a look and I find out that this Windows server uses 50 megabits of space on average per day for its logs. So that's logs per day. All right, there we go. Cool. I've got kind of a baseline at this point. Now, I want to keep these logs for 30 days. All right, that tells me I'm going to need to multiply this 50 meg by 30. And that comes out to 1,500 megabits. There we go. So now I know how much I need for that one server. Okay, now let's say I've got 10 servers in my environment. Well, then I'm going to multiply this by 10, and that's going to tell me I need 15,000 megabits of storage to store my logs in, because this is going to allow me to keep 30 days of logs roughly, right? That's kind of roughly. So what we'd want to do is, let's say, plus or minus 20%. So I would kind of do that, and that'll give you a little bit of a breather there. And you need to make sure you have enough space to store the logs. But here's the question. Where are you going to put them? It's a very good idea, because you can't leave your logs just on your server if you want to keep them for a long time, unless you want to add a bunch of storage to your server. And here's why. On your systems, by default, they keep logs in a rotating basis. So what happens is they allocate, I'm just going to make this up, I'm going to say they allocate 100 megabits of disk space to the logs. Okay, so when that 100 megabits is reached, once you have filled up that 100 megabit bucket, well, guess what happens? Well, it starts to overwrite the oldest events. So you have this continuous cycle. So if it's 100 megabits and you use 50 megabits a day, that means you're only going to keep about 2 days worth of logs. So if there's an event that happens that you need to investigate and it's older than 2 days, well, guess what? You're out of luck. You're not going to find that data you need during your investigation. So that's why we need to figure out how much log activity do we have? How long do we need to keep our logs? We need to estimate this. We need to figure out how much storage we need. Okay, and then we need to figure out where are we going to put it, because most likely we're going to offload it from our servers to somewhere else, and that somewhere else is the question. And oftentimes people turn to a SIEM. This is a security information and event management system. And here's what it does. It is a database-driven system. It ingests logs from servers, from network devices like firewalls, IPSs. It can ingest data from applications. It can ingest data from just about anything. Then the security part comes into play. It does data analytics. So it does analytics on all these events, and it uses things like threat intel feeds. So it's getting information about recent threats and such. And it takes a look and sees what is normal and what's abnormal. Is there a security problem? And it can send out alerts. It can create reports. It does all these things for you. And if we're feeding all of these logs in here already, well, wouldn't this be a great place to just keep our logs for, let's say we want to keep them for 3 months. Wouldn't this be a great place to keep our logs for 3 months since they're already there? Well, yes, it would. However, not all SIEMs allow for this. And that's because they're database-driven systems. The more information you put into them, well, guess what? The more data they have to deal with. And that can slow them down big time. And we don't want that. So what SIEMs don't do? Well, SIEMs in general, I'm not going to say every SIEM out there, because there's always those that do something that others don't. They generally do not perform long-term log retention. That's not really what they're built for, because as I said, they're database systems. When you keep adding more and more and more data and you don't offload data, they become slow, and that's something we don't want to have, because I've dealt with SIEMs that were overloaded with data, and when there was an event and I needed to go and analyze data, I'd look it up in the SIEM. It might take 10 minutes to get a simple query result. It was that slow, and that's unacceptable. There's an event going on. I need data, and I need it now. So oftentimes, when it comes to our SIEM, we need to perform an export of data from our SIEM. Maybe once a month, we're going to export that data to somewhere that we can store it, and we can hold on to it for however long we want to retain our logs. So that's something to keep in mind. When it comes to logs, we need to think about how long we want to retain them for, how much storage we need, and where we're going to put these things. And that is log storage. I hope it's been informative for you. I'd like to thank you for viewing. In the last video, we talked about logs, where to store them, and that we might need to perform audits on those logs. Well, if there is a security incident of some sort, then yeah, we're going to have to dive in and perform some analysis on those logs. And if we're collecting information for, let's say, some event investigation, well, we're going to have to record that information in what's called a chain of custody. So let's jump in and talk about a chain of custody and something called non-repudiation. So a chain of custody, what is it? Now this is a document, so we'll put it over here. It is a document, and this document is going to contain some very important information. It's going to record the life cycle of evidence that has been collected. So if you're investigating an incident and you're collecting evidence, then you will use a chain of custody. And it's meant to protect and preserve the integrity of the evidence. That's very important. It's meant to preserve the integrity of the evidence because it's recording everything that happens during the life cycle of the evidence to make sure it's always in proper hands. Now, what would this chain of custody record? Well, that's a good question. So it's going to record the evidence that was collected. It's going to record when it was collected. It's going to record where it was collected. It's going to record, guess what? Who collected it? That's right. It's going to record who collected that evidence. It's also going to record any time the data is moved, or that evidence, anytime it's moved from one place to another, it's going to be recorded. Any type of work or analysis that's performed on that data, on that evidence, it's going to be recorded. Anything that happens to that evidence, it's going to be recorded. Date and timestamps, who was involved, who had control of it. And again, this is looking to preserve that integrity of the evidence by recording the life cycle of the evidence. Now, when it comes to the cloud and chains of custody, well, I'm going to tell you, it can be difficult, as you could imagine, because we don't have access to every little thing. So if you are in a regulated industry, then you need to take the time to make sure your contracts with your cloud provider, they include some information, some wordage about your chain of custody, and that they will help you with discovering information and providing that to you. That's how we deal with it in the cloud. It really comes down to making sure it's in your contracts, and that is the chain of custody. Now, I also mentioned we're going to talk about something called non-repudiation. So what is non-repudiation? Now, this is the idea that a person cannot deny they did something, right? So that is proof that a person did something, right? That's what we're trying to do here. That's what non-repudiation is all about. Not being able to say you didn't do something. And this really is a two-sided coin. Now let's look at an example. We need proof that a person sent or created an email. Well, when we're dealing with emails, oftentimes we can use digital signatures. And this is where a user will use their private key, this is a cryptographic key, to digitally sign an email. And then they send it out. That way, the recipient, they can take that email with that digital signature and they can verify it against that person's public key. And once they do that, they know that this is authentic and that this person is the only person who could have sent that email because they're the only one who has access to this private key. And that's why this person over here cannot deny that they did something. They can't deny that they sent this email since it was signed with their private key. And that's an example of non-repudiation. But that is also a good thing if you think about it. We're going to look at the other side of this coin, right? This is our coin here. Put a little person on there. The one side is that the person can't deny they did something. The second side of that, if we flip it over, was to say they can prove they did something. For example, this right here. They can prove that that was the email they sent. Somebody didn't spoof it. This is the real thing. So we have proof that someone did something, and that's the flip side of that coin. So you can look at this from two different ways, but really it's the ability to say, yes, I did something, or to say, that person, they did it, and they can't say they didn't. And that's what non-repudiation is all about. Another example of this, if it's not quite clear yet, let's say you go to the bank to deposit $100. So you're over here, you walk into the bank, you talk to the teller over here, and you show the teller your ID. There you go, that proves that it's you. They look up your picture of you and verify that it's you. They take your fingerprint. There we go, it's your fingerprint here. And they verify that that fingerprint is your fingerprint. They know it's you. And now you deposit the $100, and they can validate that you deposited $100. You can't say you didn't. They checked it. They got your picture. They got your fingerprint. That is non-repudiation at its finest. So hopefully that helped to clear it up for you a little bit in case it was a little fuzzy. So that's all about our chain of custody, making sure we control the life cycle of evidence that we collect, we preserve its integrity, and of course, non-repudiation. I hope this has been informative for you. I'd like to thank you for viewing.